All right, so welcome to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, in this session, what we are going to do, we are going to have a one-shot complete revision of motion in the straight line. Okay, so guys, on this channel, we already have completed the motion in a straight line chapter completely. Okay, but for the new students, the students who have joined recently, I have come up with this live session in which I'll be completing the whole motion in one dimension, that is motion in a straight line in one go. Okay, so this would be the complete revision session of this motion in the straight line, and obviously the concept that we are going to attain here will help us in the motion in the plane chapter also. Okay, so guys, in this session we'll be having a complete revision. We'll do the complete thing. We shall do the complete thing. Okay, so I'm hoping that my voice and everything is fine. Yeah. So, guys, in this session, we are going to complete, as I was saying, motion in a straight line, that is, motion in 1D completely in one go. It would be a one shot session and it will be dealing with everything that you require in motion in a straight line chapter, that is, motion in one dimension. Okay. Okay. Now, so basically, when we talk, so before I start with the session, let me introduce myself, guys. My name is Dr. Shankar Sir. I have done PhD and MTech from IIT Roorkee, that is Indian Institute of Technology Roorkee. I have qualified a prestigious examination named as GATE, and I have qualified it with 99.99 percentile, and I have qualified it almost 4 times. Okay, so I have 11 years of teaching experience and I have mentored many IIT JEE NEET students. Moreover, I am author of 3 internationally published research papers. You can find my profile at Google Scholar as well and can have a look at the research papers. And moreover, I am internationally recognized author and editor to some scientific journals. Okay, so this is a brief introduction of myself. Now, let's continue. So, guys, in this session, what we are going to do, so we are going to talk about motion in a straight line, which is basically a part of the kinematics, which is basically a part of the kinematics. So, basically, in our physics, when we call about the kinematics, when we say kinematics, basically it includes two topics. Okay, it includes two topics. One is our uh, motion in a straight line, that is what we are going to deal today, and the other is motion in a plane, which requires the help of vector. Okay, so we are doing into that. Okay, so lastly we have completed the projectile motion, and projectile motion, after projectile motion we entered into relative velocity in 2D. We have done Rainman problems. In the coming session we'll be do the riverboat problem as well. Okay, okay, so afterwards circular motion will be left, that will also try to do very soon. So the kinematics will be completed. Okay, now talking about the motion in a straight line, it is a part of kinematics. Okay, now in kinematics, see what is the approach that we have to take. So kine means motion and matics means obviously mathematics. So in this, basically what we have to talk about, what things makes or describes the motion of a body, of motion of a particle, or motion of anything. So basically the first thing is displacement, then velocity, okay, then acceleration, then jerk. So jerk is normally not asked in the examination. So basically we'll be talking about this only. Now when we talk about the displacement, this is this is just a minute. Yeah, yeah. So when we talk about the displacement, basically it is a vector quantity, as we know. Okay, so the counter to displacement is distance. Okay, and velocity will be having the speed. So basically in this chapter we are going to sort out all these things. Okay, will be just a moment. Yeah, okay, just a moment, guys. There is some technical issue, it seems to me. To the live students, welcome to the session, guys. Just a moment. There is some technical issue, it seems to me. Just give me a moment. I'll look into it. Okay. So as I was saying, basically in kinematics, these are the things that we need to, take care of: distance, velocity, acceleration, distance, and speed. So in this chapter, basically we are going to talk about all these things. Okay. Okay. So first of all, let's take up the distance and displacement. Okay. So I'll be a little quick in this session. Okay. Whenever you feel any difficulty, you can always ask me to slow down, or ask me to, you know, explain again the live student. So let's talk about the distance and let's talk about the displacement. Okay. And what I suggest before you guys watch this session, I suggest you to watch the vector session completely. Okay, I have given one short vector session also, in which we have done the complete revision of the vectors. Okay, so before seeing that, if you can watch that session, that would be of great help to you as well as to me. Now, distance, we understand it is a scalar quantity. Okay, so it has nothing to do with the direction. Okay, only magnitude is required to explain the distance, right? Whereas when we talk about the displacement, it is a vector quantity. It is a vector quantity which require both magnitude and direction, both magnitude and direction to represent. Okay, so also see, I many times have said this in my sessions that the vector is not the thing which only has magnitude and direction, but it also follows the laws of vector addition, right? Okay, remember that. So displacement basically is a vector, and to present a vector, basically you are requiring two things. One is the magnitude, other is the direction. Remember that. Okay. For distance, only magnitude is suffice. Okay. Okay. Like for example, see what is the displacement, what is the distance. So basically, distance is what? Let's suppose that someone has started moving from this point A, moves towards 5 meter east, okay, and then moves towards, let's suppose, 5 meter north, and reaches this point B. Reaches this point B. So what is the distance basically? So distance is basically what? It is the actual path followed by any particular object, particle, man, woman, anything. Okay. Okay. So what is the distance there? See, simply distance doesn't require any direction. Okay, it only requires to be explained by the magnitude, that what is the how much distance, that what is how much path you have followed, how much you have went for. Okay, so distance, if I am talking about, so this is basically 10 meter, 5 meter, and 5 meter. This is basically 10 meter. Okay, if you have afterwards, if you have moved returning towards the east like this, okay, 5 meter, the distance will become 5 more meter. Okay, that is 15 meter. Then if you come back to a point, if you come back to a point, you can add further 5 meter. Okay, okay. So this is your distance. Okay, so whatever actual path you are following, that is going to be called upon as your distance. But what is displacement? So, sir, Displacement we understand. So basically, displacement is also kind of a distance, but it is the shortest distance. It is the shortest distance, okay, between shorter distance between initial and final position, between initial and final position. Okay, so let's suppose someone has took some path, okay, and he has moved by some, some distance. Okay, so initial and final position, so someone has moved by a distance. Okay, let's suppose he has moved like this as I have put it here. Okay, so whatever is the actual path followed, whatever length of actual path followed is going to be called upon as your what, sir? It is going to be called upon as your distance, right? But the shortest distance between the initial and the final position, the shortest distance between initial and final position will be known as the displacement, will be known as the displacement. So now in this case, what is going to be the displacement? So someone has moved to A and he came back to that, or she came back to that very position, that is A. So in that case, the displacement is going to be what? It is the minimum distance or the shortest distance between initial and the final position. So the displacement is going to be 0. I hope it is fine to everyone. Okay, so we have the distance, we have the displacement here. Like for example, if I say someone has moved from this point A and this point towards B. So let's suppose this is 4 meter he has moved here, 3 meter he has moved here. Okay, from A to B he went, then from B to C he went. Okay, now in this case, what is going to happen? So what is the distance he traveled? What is his distance? Can you tell me what is going to be the distance here? So the distance is obviously 4 plus 3, that is 7 meter. But what is going to be the displacement? So displacement is going to be, see, the shortest distance between A to C. And what is going to be the shortest distance? So if I join A and C, if I join A and C together, this is going to be your shortest distance, right? Now, what it is going to be, so we are very much comfortable with saying that we can apply the Pythagoras here, and we can say if this is 4, this is 3, so obviously this is going to be 5 meter. So the displacement is going to be 5 meter. Yes or no? Yes or no? Here the displacement is 0 meter. So basically the displacement depends upon the initial and the final position of any particular object, particle, a boy, body, anything. Right? I hope the displacement thing is clear to you guys. What is the displacement? What is the distance? Okay? Very, very simple, sir. So basically displacement is what? Displacement is the shortest distance between initial and final position. So we can say that the displacement is always less than or equal to the distance, right? Because see, let's suppose someone has moved from A to B only. Okay, let's suppose this is your 5 meter. Now, what is going to be the distance? What is going to be the displacement? What is going to be the distance and what is going to be the displacement? So both are same only. Okay, because from A to B, the shortest distance is also this 5, right? Okay, so see, this is very, very important to do. Okay, because we'll be dealing with the displacement a lot. Okay, in the equations of motion also we will be, ये देखिए, मेरी एडवाइस ये नहीं है आपको, ठीक है? फिलहाल आप चाहें तो पढ़ सकते हैं, कोई बुराई नहीं है, लेकिन आप देखो यार, एग्जाम आने वाला है, आप 2024 टारगेट कर रहे हो, 25 टारगेट कर रहे हो? अगर 25 टारगेट कर रहे हो तो जो मर्जी पढ़ो, पढ़ लो अभी ट्रिग्नोमेट्री, कोई दिक्कत नहीं, ठीक है? डिफरेंशिएशन भी पढ़ो, ट्रिग्नोमेट्रिक पढ़ो, थोड़ा डिफरेंशियल इक्वेशन भी पढ़ना फिर, और बेहतर समझ में आएगा, समझ रहे हो? ठीक है, लेकिन अगर 24 की तैयारी कर रहे हो तो देखो टाइम है कम, बायोलॉजी भी रटनी है, केमिस्ट्री भी रटनी है, ऑर्गेनिक केमिस्ट्री भी रटनी है, फिजिक्स भी पूरी करनी है, प्रॉब्लम सॉल्व करने हैं, उसमें अपना टाइम, मतलब मेरी एडवाइस है कि रहने ही दो। अगर 24 के लिए कर रहे हो तो उसके बाद कर लेना ना, पढ़ने का मन कर रहा है तो क्या दिक्कत आ रही है? पढ़ने से कौन रोक रहा है ना? ठीक है। हाँ जी। सो इन दिस केस देखिए डिस्प्लेसमेंट डिस्टेंस दोनों क्या है, दोनों बराबर है, क्योंकि शॉर्टेस्ट डिस्टेंस भी यही है जो एक्चुअल डिस्टेंस है। हाँ तो पढ़ लो, अगर मन कर रहा है तो पढ़ लो, क्या दिक्कत है फिर। इतना इसके बारे में इतना सोचने में इतना टाइम वेस्ट हो जाएगा, उतनी देर में तो पढ़ लोगे भाई, पढ़ लो, कोई दिक्कत नहीं, पढ़ लो। ठीक है। ओके। चलिए। हाँ पढ़ लो बेटा, पढ़ लो, अगर इतनी प्रॉब्लम है तो पढ़ लो भाई, कोई दिक्कत नहीं है। पढ़ना, पढ़ने में कोई बुराई नहीं है, पढ़ लीजिए आप। है ना, अगर आपका कंसंट्रेशन नहीं बन पा रहा, आप चाहते हैं कि पढ़ें पहले ट्रिग्नोमेट्री, तो आप पढ़ लीजिए, कोई दिक्कत नहीं है। ठीक है। आइए करते हैं, बात करते हैं। तो अब डिस्टेंस, अच्छा ये बताइए मुझे, ये मोशन इन स्ट्रेट लाइन आपको समझता है बेटा, ठीक ठाक? अगर नहीं समझता तो ये सेशन में जुड़े रहिए, इसी सेशन में पूरा कंप्लीट कर देंगे इसको, मोशन इन स्ट्रेट लाइन, क्वेश्चन वोश्चन भी जो जो ठीक ठाक है वो देख लेंगे। ठीक है। ओके। राइट। तो देखिए अब ये जो डिस्टेंस डिस्प्लेसमेंट वाला फंडा है, इस पे भी कुछ क्वेश्चन बन जाते हैं। जैसे मान लीजिए कहा जाए आपसे कि मान लीजिए एक पर्सन है, ए से चला और इसने एक सेमी सर्कुलर पाथ लिया, क्या लिया, एक सेमी सर्कुलर पाथ लिया बी तक। ठीक है। ए से गया, ठीक है, अच्छी बात है बेटा। तो ए से गया, सेमी सर्कुलर पाथ लिया बी तक, और जो सेमी सर्कल ये चला उसका रेडियस था आर, रेडियस आर था। ठीक है। अब इस केस में आप बताइए कि व्हाट इज द डिस्प्लेसमेंट, डिस्प्लेसमेंट क्या होगा, बताइए। वेरी वेरी सिंपल, है ना, बोलिए। व्हाट इज गोइंग टू बी द डिस्प्लेसमेंट इन दिस केस? सो सर आप कहोगे सर हम जानते हैं कि डिस्प्लेसमेंट इज द शॉर्टेस्ट डिस्टेंस बिटवीन टू पॉइंट्स। तो शॉर्टेस्ट डिस्टेंस क्या बनेगा सर, ए और बी के बीच का शॉर्टेस्ट डिस्टेंस बन गया ये। ठीक है। तो अब ये रेडियस आर है, तो ये कितना है सर, ये है 2r, राइट। तो व्हाट इज गोइंग टू बी द डिस्प्लेसमेंट सर, डिस्प्लेसमेंट इज 2r, है ना। इसी तरीके से और भी कई क्वेश्चन यहाँ पे बना देते हैं सर्कल वगैरह का यूज करके। ठीक है, मान लीजिए ये बना दिया आपका। ठीक है। कहा कि भैया किसी ने स्टार्ट किया यहाँ से और इसने फॉलो किया एक पाथ, और ये पहुंच गया यहाँ बी पे, ये पहुंच गया यहाँ पे बी पे, और इसने जो एक्चुअल पाथ फॉलो किया है ए टू बी तक, ये है क्वार्टर ऑफ सर्कल। ठीक है, एक चौथाई सर्कल के बराबर की डिस्टेंस इसने फॉलो की है, मतलब ए से चला और क्वार्टर सर्कल पे आकर के रुका। तो बताइए व्हाट इज गोइंग टू बी द डिस्प्लेसमेंट, बताइए डिस्प्लेसमेंट क्या होगा, बोलिए, बोलिए। बोलिए। क्या होगा, तो आप कहोगे सर बहुत ही सिंपल सी बात है, इसमें तो कोई दिक्कत की बात नहीं है। सर हमको पता है जो डिस्प्लेसमेंट होता है वो होता है शॉर्टेस्ट डिस्टेंस बिटवीन इनिशियल टू फाइनल पोजीशन। तो बेसिकली ये हो गया डिस्प्लेसमेंट, राइट, ये है हमारा डिस्प्लेसमेंट। तो इसको कैसे निकाल सकते हैं सर, ये है आर, ये है आर, तो ये कितना हो गया, ये हो गया √2 ऑफ आर, राइट, √2 ऑफ आर, राइट। तो बेटा ऐसे ही अगर आपको कभी कहे तो चलो इसको थोड़ा सा जनरलाइज भी कर लेते हैं। तो देखिए कैसे जनरलाइज करेंगे, हम थोड़ा सा वेक्टर का यूज कर लेंगे। ठीक है, आपने, इसलिए मैंने कहा कि आप थोड़ा सा वेक्टर अगर पहले से पढ़ के रखें तो ज़्यादा बेटर होता है मोशन अंडर कांस्टेंट ग्रेविटी के प्रॉब्लम्स को समझने के लिए, है ना, मतलब थोड़ा आइडिया रहता है तो अच्छा रहता है। ठीक है। तो मान लीजिए कोई चला, यहाँ से चला, यहाँ से चला, ठीक है, और यहाँ पे कहीं पहुँचा। ठीक है, कोई चला यहाँ से और यहाँ पे कहीं पहुँचा मान लीजिए। ठीक है, यहाँ पे कहीं पहुँचा, तो यहाँ से यहाँ तक पहुँचने में इसका डिस्प्लेसमेंट कितना होगा, ए से बी। ठीक है, तो इसको जनरलाइज कर लेते हैं, कैसे जनरलाइज कर सकते हैं, चलिए इसको इससे जोड़ लिया हमने। ठीक है, वी हैव कनेक्टेड दीज टू। अब देखिए क्या है, बड़ी सिंपल सी बात है। देखो देखिए, मान लेते हैं ये है R1, ये है R2। सर ये तो आर ही है लेकिन वेक्टर बना दिया ना। वेक्टर यूज करूंगा तो देखिए वेक्टर में क्या होता है कि दो अगर कोई क्वांटिटीज है, इवन दो उनका मैग्नीट्यूड भले ही सेम हो, उनका मैग्नीट्यूड भले ही सेम हो, लेकिन अगर डायरेक्शन डिफरेंट होती है तो वो सेम नहीं होती। इसीलिए मैंने दोनों को आर एंड आर नहीं लिखा, ठीक है, क्योंकि दोनों की डायरेक्शन डिफरेंट है। जब डायरेक्शन डिफरेंट होती है बेटा तो वेक्टर डिफरेंट होता है। तो R1 है, ये R2 है, और ये है मेरा डी वेक्टर, मान लीजिए ये है मेरा डी वेक्टर। ठीक है, तो देखिए R1 डी और ये R2, तो लॉ ऑफ ट्रायंगल क्या कहता है? लॉ ऑफ ट्रायंगल बेटा हमारा क्या कहता है, बताइए? लॉ ऑफ ट्रायंगल्स ऑफ वेक्टर। ठीक है, तो बेटा क्या है, मान लीजिए R1 और R2 के बीच का एंगल है थीटा। तो यहाँ से बेटा हम क्या लिख सकते हैं, देखो यहाँ से हम क्या लिख सकते हैं, यहाँ से हम लिख सकते हैं, देखिए R1, ठीक है, प्लस डी वेक्टर, R1 वेक्टर प्लस डी वेक्टर इज इक्वल टू R2 वेक्टर। ठीक है, R1 वेक्टर प्लस डी वेक्टर इंटू R2 वेक्टर। देखिए कैसे करते हैं, बाय लॉ ऑफ ट्रायंगल ऑफ वेक्टर्स क्या कहता है कि इफ टू वेक्टर्स आर रिप्रेजेंटेड बाय टू साइड्स ऑफ अ ट्रायंगल टेकन इन द सेम ऑर्डर, जैसे R1 और D जो है आपको दो वेक्टर दिख रहे हैं जो एक ही ऑर्डर में है। Okay, the resultant of these vectors is represented by the third side of the triangle in magnitude and direction taken in opposite order। ठीक है, तो यहाँ पे आप देख सकते हैं कि R1 वेक्टर और D वेक्टर जो है वो एक ही सेंस में है और ट्रायंगल की दो साइड बना रहे हैं। तो जो तीसरा वेक्टर है R2 वेक्टर है वो क्या दिखा देगा बेटा आपको, वो दिखा देगा इस का रिजल्टेंट। तो R2 वेक्टर क्या हो गया बेटा, R2 वेक्टर हो गया R1 वेक्टर प्लस D। ओके, R1 वेक्टर प्लस डी, तो यहाँ से आप डी वेक्टर क्या लिख सकते हैं सर, हम ऐसा लिख सकते हैं क्या इसको, R2 वेक्टर माइनस R1 वेक्टर, राइट? ओके, तो डिस्प्लेसमेंट वेक्टर क्या है, ये है इन दोनों वेक्टर का डिफरेंस इस केस में जब ये सर्कल के अंदर ऐसा घूमता है। ठीक है, सर्कल के अंदर ऐसा घूमता है, राइट? अब बेटा इसका हमें क्या निकालने का है, इसका हमें रिजल्ट मतलब डी निकालने का है। तो डी का मैग्नीट्यूड क्या हो जाएगा बेटा, व्हाट विल बी द मैग्नीट्यूड ऑफ डी? तो ये क्या हो जाता है बेटा, ये हो जाता है रूट ओवर, देखिए R2 स्क्वायर, सर वेक्टर सब्सट्रैक्शन। तो वेक्टर सब्सट्रैक्शन कुछ नहीं होता, ये वेक्टर एडिशन ही होता है। नो, अगर आप वेक्टर का सेशन देखोगे मेरा तो आपको ये बात क्लियर होगी। तो ये है R2 वेक्टर माइनस प्लस ऑफ माइनस R1 वेक्टर, राइट? इसको आप ऐसा लिख लो, ठीक है, और लगा दो लॉ ऑफ पैरेललोग्राम ऑफ वेक्टर्स। सो R2 स्क्वायर प्लस R1 स्क्वायर माइनस टू टाइम्स R1 R2 कॉस थीटा। ठीक है, ये आपको फॉर्मूला मैंने दिखाया था, ये एक्सप्रेशन हमने बनाया था जब दो वेक्टर्स के बीच में निगेटिव का साइन होता है उस कंडीशन में। ठीक है, वेरी वेरी सिंपल सर। तो डिस्प्लेसमेंट वेक्टर का मैग्नीट्यूड आपका क्या बन जाएगा, ये बन जाएगा। तो अब देखो इस केस में R2 R1 दोनों का मैग्नीट्यूड क्या है, R2 R1 दोनों का ही मैग्नीट्यूड है R, क्योंकि ये बेसिकली रेडियस ऑफ द सर्कल दिखा रहे हैं। तो ये भी हो गया R, ये भी हो गया R, ये है R, ये भी है R, यानी R स्क्वायर कॉस थीटा। तो बेसिकली ये कितना बन गया, ये बन गया R रूट ओवर 1 - 2 कॉस थीटा। सर ये कैसे किया, तो नहीं, टू भी आएगा ना, टू भी आएगा, ठीक है। तो टू, इसको अंदर ही रहने दो, चलो कोई नहीं। ये कितना बन जाएगा, देखो आर स्क्वायर प्लस आर स्क्वायर, ये हो गया 2R स्क्वायर, 2R स्क्वायर माइनस 2R स्क्वायर कॉस थीटा। तो ये हो गया 2R स्क्वायर 1 - cos थीटा, 2R स्क्वायर 1 - cos थीटा, राइट? ओके, 1 - cos थीटा। अब बेटा ये 1 - cos थीटा कैसे निकालेंगे, तो cos 2 थीटा कितना होता है, ये होता है 2 1 - 2 sin² थीटा, राइट? है ना, थोड़ी सी ट्रिग्नोमेट्री लगा लेंगे, ट्रिग्नोमेट्रिक का एक्सप्रेशन लगा लेंगे। तो यहाँ से हम ऐसा लिख सकते हैं कि cos थीटा इज इक्वल टू 1 - 2 sin² थीटा/2, राइट? तो 2 sin² थीटा/2 इज इक्वल टू 1 - cos थीटा, 1 - cos थीटा। ओके, तो 1 - cos थीटा को हम ऐसे लिख दें 2 sin² थीटा/2। तो ये कितना बन गया, ये हो गया 4R स्क्वायर sin² थीटा/2। साइन स्क्वायर थीटा बाई टू। तो बेटा यहाँ से इसका डी का क्या फॉर्मूला बन गया, इसके मैग्नीट्यूड का। ठीक है, कई लोग इसको ये फॉर्मूले की तरीके से भी याद रखते हैं। तो इसका मैग्नीट्यूड का फिर फॉर्मूला क्या बन गया बेटा, यहाँ से हमने इसको ले लिया बाहर, ये हो गया 2r साइन स्क्वायर थीटा बाई टू, यानी साइन थीटा बाई टू। ठीक है, तो ये बन गया हमारा डिस्प्लेसमेंट वेक्टर। ये बन गया बेटा हमारा डिस्प्लेसमेंट वेक्टर। क्लियर है बेटा? प्लीज आंसर मी, बोले जो लाइव स्टूडेंट्स है कैन रिस्पॉन्ड टू मी, राइट? ओके, सो ये बन गया बेटा हमारा वेक्टर डिस्प्लेसमेंट का, उसका हमारा मैग्नीट्यूड निकल आया, राइट? सो वी हैव गॉट द मैग्नीट्यूड ऑफ इट। ओके, we have got the magnitude of it. So see, what is the, oh, so I was, very good morning Shwami. So I was speaking Hindi in the flow. Okay, okay, no worries. So just I'll give you a flashback. So in this case, so what is firstly what we have seen? We have seen the difference between the distance and displacement. Now we are sorting out few problems. So we understand that the Shwami, very good morning. So, my dear, what we are doing here? So, on this channel, first of all, we have completed the motion in a straight line already in various sessions. So, I am here to have a one short session so that we can have a complete revision of motion in a straight line. So, in one session, I'll be completing everything. Okay. Now, in this order, what we are trying to see, we are trying to figure out what is the, firstly, what is the difference of distance and displacement, and we are trying to solve some problems. Okay. So now in this case, like many times they ask you this question, very, common question. So with very common question, this is that your something has moved, or something has traveled along a circular path. It may cover half circle, quarter circle, or a portion of circle. Now in that case, what is going to be the displacement? So we try to make a formula for it. So whenever something is moved in a circular path, okay, what we can do, we can use this concept. What concepts are this one? D is equal to 2r sine theta by 2. So if we want, we can directly apply this formula. Okay. Okay. So let's suppose, for example, so in this also, like, so in this you see the angle between these two is 90 degree. You have to take care of this angle. So if you apply this formula, what we are getting? Say sine 90 by 2, that is sine 45. Sine 45 is 1 by root 2. So it is going to be root 2 of r. Root 2 of r. Like for example, if it is said like something has moved like this, okay, this is point A and this is point B. This is point A, this is point B, and this is 120. This is 120, let's say. Okay, so from this point A to this point B, what is going to be the displacement? So the displacement is going to be this. Okay, this is going to be the displacement. So what is going to be the displacement? It is going to be r sine theta by 2. Okay, so what is r sine theta by 2? Sine theta by 2 is going to be, sorry, it is 2r sine theta by 2. So 2r sine theta by 2, that is sine 60. And what is sine 60? Sir, it is root 3 by 2. It is root 3 by 2. So it is going to be root 3 of r, right? So this way, using this formula, we can, solve this, or otherwise we can do some geometrical thing. Like for example, this is r, this is r, this is D. So you may apply the sine rule also if you want. Okay. Okay. I hope this kind of a question you will be able to take care of. Let's try one more question then. Let's try this one. Let's see if we can do it or not. That's right. How can we do it? Any answer to this, Buddha? That's right, Buddha. Any answers? So what does this say? So it says a wheel of radius r is rolling on the road. What will be the displacement of a point P in half rotation of wheel on the road? So how we got to do it? So a wheel of radius r is rolling on the road. Okay, very well. So we are having a wheel here. Okay, we are having a wheel here. Now it is rolling on the road. What will be the displacement of a point P in half rotation? So basically, it has done half of the rotation, half rotation. So after half rotation, what is going to be? So what will be the displacement of point P actually they are asking. So this is the point P initially, na? I haven't given you the point P. Sorry, my bad. Okay. This is your point P. Okay. Now a wheel of radius r is rolling on the road. What will be the displacement? What will be the displacement of a point P in half rotation of the wheel on the road? Now when it makes half the rotation, when it makes half the rotation, this P point is going to be here. This P point is going to come here. Do you agree to it or not? This P point is going to reach here, isn't it? Yeah. Yes, sir, absolutely. It is going to reach here. Okay. Okay. So half the revolution, it will take some forward because it is rolling now. So rolling means that something is moving forward also, it is rotating also. Rolling is basically to some extent translation and translation and this rotation. So this is P, this is going to be the P, this is the point P. Okay. And now from here to here, what is the distance it has moved by? So obviously, sir, it has moved by pi into r because it has rotated by the half rotation. It has taken half of the rotation now. So when it has taken half the rotation, beta, when it has taken half the rotation, this is what it going to be like. right? This is what it is going to look like, right? So this particular, thing will move forward by the distance of pi r, and this pi will be at this position. Do you agree to this or not? Please answer me. Yes, sir, absolutely, we agree. Now, what is the displacement? So now many students say that sir, it is going to be pi r, which is wrong actually. What is the displacement, sir? It is the shortest distance between this position to the final position. Shortest distance between the initial and the final position. So basically, this is how much? This is 2r. This is 2r. This is pi r. This is 2r, and this is what? This is pi r. So what is going to be the shortest distance? That is the displacement. So displacement will be the distance when you join these 2 points, right? Like this. So what is going to be the d? So d is going to be root over pi r square plus 2r square. Fully. Is that clear? Beta? Please answer me. Please give me a yes or no. Right? Very, very simple, isn't it? Right? So I think with this, the displacement and the distance thing is sorted. Right? Displacement and the distance thing is sorted. Now let's talk about the speed and the velocity. Speed and velocity. Okay? Speed and velocity. Now what is going to be this speed and velocity? Sir, again we understand this one thing, first of all, that speed is a scalar thing and velocity is a vector thing. Okay, this is a scalar thing and this is a vector thing. Okay, okay. So now when I say scalar and vector, we obviously get this, that speed is having only magnitude and velocity is also having magnitude as well as the direction. Okay, it is requiring magnitude as well as the direction, right? Okay, it requires magnitude as well as the direction. Okay. Now, when I talk about the speed and velocity, there are two things that is needed to be taken care of. Okay. So first of all, we understand that what is the speed? So speed is the distance, that is change in distance upon change in time. Okay. Like if we want to define it, it is change in distance upon change in time. Okay. And what is going to be the velocity? So velocity, it is going to be change in displacement upon change in time. Change in displacement, I shall write a little bit about. So velocity is what, beta? Velocity is change in displacement upon change in time, right? Okay. Now, basically, in this chapter, we need to deal with the two things of speed and velocity. So, one is the average speed and average velocity. Okay, average speed and average velocity. Okay, and this is basically the other thing is your instantaneous speed. Instantaneous speed and instantaneous velocity. Okay, so here this further we have to deal with. So when we talk about the speed and velocity in this chapter, we need to take care of two things. One is average speed and average velocity. Another is instantaneous speed and instantaneous velocity. So for instantaneous speed and instantaneous velocity, we require a little bit concept of differentiation. Okay. So differentiation. So if you don't know differentiation, so firstly I'll deal with the average speed and average velocity concept. But if you don't know the concept of differentiation, on this channel, I have given you one session on differentiation for kinematics. Okay. So in that, I have taught you the differentiation, which is just sufficient for the understanding of what? For the understanding of uh, uh, in kinematics or the physics that you require to do for the NEET examination. Okay, so when we'll be talking about the instantaneous speed and instantaneous velocity, I request you to watch that session before you proceed. Okay, now let's first talk about the average speed and average velocity. Okay, so see, very simple. When we talk about the average speed and velocity, it is very simple. Average speed and average velocity. Okay, so see, very simple concept. What is this average speed, sir? So average speed is basically total distance. It is total distance upon total time. Total distance upon total time. Whereas the average velocity is total displacement upon total time. Total displacement upon total time. I hope it is fine to everyone. Okay. Okay. So see, simply using this concept, you can deal with it. Like for example, let's try one question. So let's say, let me make a question. So let's say a boy walks 3 meter east in 2 seconds. Okay, remember this formula. Total distance upon total time, total displacement upon total time. Very simple. So a boy walks 3 meter east in 2 seconds and and 2 meter west, 2 meter west and 2 meter west in 3 seconds. Okay, 2 meter west in 3 seconds. Find average speed. Find average speed and average velocity. Can we please try this? Can we please try it? A boy walks 3 meter east in 2 seconds and then 2 meter west in 3 seconds. Find average speed and average velocity. Please try it. I'm very sure we can do. Please try it. Please do it, beta. See, to solve the question, always first try to draw a little bit of figure that you can. It says a boy walks 3 meter east. Okay, so let's take this boy to 3 meter east. So he walks 3 meter of east. Okay, in 2 seconds and 2 meter west in 3 seconds. 2 meter west in 3 seconds. So now after reaching 3 meter east, he came back towards the west and it took 3 seconds. So how much he traveled? What is the average speed? So what is the average speed first of all? So average speed is the total distance upon total time, total distance upon total time. So what is going to be the total distance? So firstly, he has moved 3 meter east, then 2 meter west. So total distance, irrespective of the direction. See, distance has nothing to do. Uh, Sine neural verb. My dear, 80 प्लस कैसे लाए? 80 प्लस में क्या होगा बेटा? 80 प्लस में तो सिलेक्शन नहीं होगा मेरे भाई। 80 प्लस लाके क्या करोगे बताओ? 80 प्लस क्यों लाएंगे? हम 150 प्लस लाएंगे, है ना? Will try to get 180, 150 plus. Now why 80 plus? Why you are settling down at such a low score? Okay, so see, it is very simple. See, physics requires. So I have explained it in some strategy videos on this channel though. But as you are asking, आप पूछ रहे हैं तो मैं बताता हूँ. देखो बड़ा सिंपल फंडा है फिजिक्स का. ठीक है? अरे तो 20 कुछ कमी है ना, 20 मार्क आ रहे हैं. थैंक यू AK. ओके, सो देखिए प्लीज ट्राई टू अंडरस्टैंड. देखो 20 मार्क आ रहे हैं मतलब कुछ कमी है. अब वो कमी ढूंढ लीजिए, उसको सॉल्व कर दीजिए. ठीक है? देखिए मैं आपको अपने एक्सपीरियंस से छोटा सा सजेशन दे देता हूँ आपको इस बारे में. देखिए फिजिक्स में अगर आपको स्कोर करना है, फिजिक्स ढंग से पढ़नी है, तो बेसिक कॉन्सेप्ट को टाइट से पकड़ लीजिए आप. ठीक है? फिजिक्स में अगर आपके बेसिक कॉन्सेप्ट क्लियर है तो काफ़ी चीज़ें अपने आप ही डील हो जाती हैं. ठीक है? ठीक है, और उसके बाद प्रैक्टिस. ठीक है, जितने ज़्यादा क्वेश्चन बनाओगे, जितने ज़्यादा टाइप के क्वेश्चन बनाओगे, उतना आपका दिमाग खुलता रहेगा. क्योंकि देखो यहाँ पे अगर आपको कोई कॉन्सेप्ट पता है तो उस कॉन्सेप्ट के ऊपर क्वेश्चन को बहुत ट्विस्ट किया जा सकता है ना? जैसे ये डिस्टेंस डिस्प्लेसमेंट वाली बात है, इसमें ही बहुत सारी कहानी बनाई जा सकती है. तो देखिए क्या होता है कि जब हम प्रैक्टिस करते हैं, जैसे अभी आपको कोई क्वेश्चन बना दिया, कुछ भी क्वेश्चन बना सकते हैं कि किसी ने कुछ स्पीड चला, अभी मैं कराऊंगा अभी आपको. तो कुछ डिस्टेंस किसी ने चला भैया, उसके बाद कुछ और डिस्टेंस चला, इतना डिस्टेंस इस स्पीड पे चला, अगला ये डिस्टेंस इतने टाइम में कवर किया, कैसे कैसे करके घुमा सकता है. फॉर्मूला एक ही है स्पीड का, डिस्टेंस अपॉन टाइम, हर जगह लगेगा यही. लेकिन क्वेश्चन को समझने की बात है, क्वेश्चन को समझने की एबिलिटी की बात है. ठीक है? तो ये एबिलिटी ऐसा नहीं है कि कोई मतलब कहीं मिल रही है, कहीं बिक रही है. ठीक है कि आप ये कर लोगे, जाओ 20 रुपए में खरीद लो, ऐसा तो नहीं होगा. हाँ, मैं उसी की बात कर रहा हूँ. न्यूमेरिकल में बेस्ट होने के लिए आपको एक काम ये करना चाहिए सबसे पहले तो कि बेसिक्स को ठीक कर लीजिए. बेसिक्स क्या है? बेसिकली आपकी यूनिट्स में गलती नहीं होनी चाहिए, है ना? कई बार यूनिट कन्वर्जन में गड़बड़ा जाता है मामला. यूनिट में गड़बड़ी नहीं होनी चाहिए. ठीक है? दूसरी चीज, थोड़ी मैथमेटिक्स आपको आनी चाहिए, थोड़ी, बहुत ज्यादा नहीं. थोड़ी ट्रिग्नोमेट्री के फॉर्मूले पता होने चाहिए. बेसिक अलजेब्रा करने में आपको ज़्यादा टाइम नहीं लगना चाहिए, ज़्यादा दिक्कत नहीं आनी चाहिए. तीसरी चीज़, आपको थोड़ा सा डिफरेंशिएशन इंटीग्रेशन समझ लेना चाहिए. हेलो वाला. ठीक है? थोड़ा डिफरेंशिएशन इंटीग्रेशन थोड़ा सा समझ लीजिए. वेक्टर अच्छे से समझ लीजिए, बहुत यूज आता है. और उसके बाद जो भी चैप्टर आप करें, ठंडे दिमाग से करिए. फिजिक्स में कॉन्सेप्ट, अगर आप फिजिक्स की थ्योरी पढ़ने चले जाओगे, केवल विदाउट क्वेश्चन थ्योरी पढ़ोगे ना, तो थ्योरी आपकी दो दो महीने में पूरी थ्योरी खत्म हो जाएगी. बायोलॉजी की तरह नहीं है कि भर भर के थ्योरी है. ठीक है? थ्योरी कम है. ठीक है? कॉन्सेप्ट ज्यादा है. एक कॉन्सेप्ट आप पकड़ते हैं, उसके ऊपर 50 तरीके के क्वेश्चन बन सकते हैं. तो सबसे पहले कॉन्सेप्ट को ढंग से पकड़ लीजिए, उसके बाद बस क्वेश्चन 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 लगाते चलिए. जितने टाइप के आप क्वेश्चन लगाएंगे उतना आपका ब्रेन जो है वो खुलता जाएगा. और आपको जब भी नया टाइप का क्वेश्चन मिलेगा तो आपकी सोचने की एबिलिटी बढ़ेगी. है ना? बस इतना करना होता है फिजिक्स में. ठीक है? बाकी मतलब बहुत इजी सब्जेक्ट है यार. ठीक है? रिलेटिवली कंटेंट कम है, आपके दिमाग में जगह कम घेरता है. बायोलॉजी की तरह नहीं है कि पूरा पूरा भर गया दिमाग. आर यू गेटिंग माई पॉइंट? Okay, now let's try this question. Okay, so what we are doing today here, so we have completed motion in a straight line on the channel already, but since many of you have joined this channel lately, so I am coming up with this whole revision session in which we'll be completing the motion in a straight line in all the respect in this revision session. Okay, so now what is the average speed here? So average speed is total distance upon total time. So the boy walks 3 meter east, 2 meter west. So what is the total distance he has covered? Firstly 3 meter, then 2 meter. Irrespective of the direction, you have to consider the magnitude only. So the total distance is 5, and what is the total time? It is 2 seconds. So firstly, it takes 2 seconds, then it took 3 seconds, so it is 5. So what is the average speed, sir? It is 1 meter per second. Very, very simple, isn't it? Now, what is going to be the average velocity? So for average velocity, sir, we need the displacement upon total time. Yeah, no issues. No issues, beta. Please try to do the revisions and practice question as much as you can. Things will be sorted. Okay, don't worry. Okay. Now please understand this. What is the average velocity, sir? So average velocity is going to be the displacement, total displacement upon total time. So what is the total displacement? So the displacement, okay, displacement is the initial, it is the shorter distance. नहीं क्या जरूरत है इतना प्रैक्टिस देखिए जब हम कंपटीशन की तैयारी करते हैं ना तो हमको बहुत ज्यादा ये सब नहीं करना होता है देखिए ये भी एक बड़ी मतलब देखिए ये मैं आपको अपना सजेशन दे रहा हूँ ठीक है कई बार हमको लगता है ना कि यार हम चीजों को प्रैक्टिकली समझ लें अरे क्या करना है इतना प्रैक्टिकली समझ के इसमें बताओ एक आदमी 3 मीटर ईस्ट गया 2 मीटर वेस्ट आया उसकी एवरेज स्पीड निकालनी है अब इसको इतना प्रैक्टिकली क्या समझ के क्या कर लोगे बताओ कुछ फायदा है इसको बताइए आप कॉन्सेप्ट अप्लाई करिए ज्यादा प्रैक्टिकली समझने के चक्कर में ना एग्जाम में टाइम लग जाता है ज्यादा और देखो ये मैं एकदम आपको फैक्ट बात बता रहा हूँ भाई मैंने एमटेक किया पीएचडी किया मैं 20 10 11 साल से फिजिक्स पढ़ा फिर 10 11 साल से पढ़ा रहा हूँ ठीक है बहुत बच्चे पढ़ाए मैंने तो ये ज्यादा प्रैक्टिकली प्रैक्टिकली ये सब बेवकूफ़ी है मेरे हिसाब से तो भाई कंपटीशन में आपके पास एक क्वेश्चन करने के लिए 40 से 50 60 सेकंड है उसमें कितना प्रैक्टिकली सब सोच लोगे एक क्वेश्चन को आर यू गेटिंग माई पॉइंट ठीक है तो ज्यादा क्वेश्चन को जब हम देखो मेरी बात आप सब लोग समझिए यस not only that bala it is also like we are approaching physics in a wrong way right like this what I feel that like in competitive examination आप बताइए मुझे एक क्वेश्चन में कितने शब्द होते हैं हाउ मेनी वर्ड्स आर देयर इन वन क्वेश्चन मिनिमम बताइएगा यू टेल मी द मिनिमम नंबर ऑफ वर्ड्स इन वन क्वेश्चन ऑफ फिजिक्स कितने क्वेश्चन कितने वर्ड्स होंगे बताइए minimum 40 to 50 words isn't it now let's consider 40 words so firstly you have to read that 40 words then you have to solve that question you have to think of the formula you have to think of everything right now in that case yeah in that case you don't have to go this practical and all those are you getting my point right so now in this case beta this is going to happen that way okay राइट सो बेसिकली व्हाट आई एम ट्राइंग टू टेल यू कि एग्जाम में इतना प्रैक्टिकल प्रैक्टिकल सोचने का टाइम नहीं होता एग्जाम में तो आपने क्वेश्चन का डाटा उठाया अपना सीन में उसको फिट किया अपना भैया फॉर्मूले में फिट किया अपने कॉन्सेप्ट में फिट किया और आंसर दिया दैट इज व्हाट यू हैव टू डू आइडियली ठीक है लेट मी टेल यू वेरी ब्लंटली right in understanding the physics you must once you feel the physics ki theek hai this is going this way that way right you understand the concept well you understand the concept by heart so you are basically improving your efficiency अंडरस्टूड आप अपनी एफिशिएंसी को इम्प्रूव करके एग्जाम में क्वेश्चन को जल्दी बना लोगे वरना 60 70 सेकंड में बेटा इतना सोचने लग जाओगे ना कि अरे यार बहुत प्रैक्टिकली सोच रहे हैं कि वो आदमी 3 मीटर तो वहीं से इमेजिन करने लग गए कि अगर मैं 3 मीटर वहां से चलूंगा फिर 2 मीटर इधर चलूंगा तो क्या होगा ये सब मत करना बेटा ठीक है इस सब की कोई जरूरत नहीं है ठीक है ओके और देखिए कुछ चीजें यहाँ पे आपको समझनी है समझना आपको ये कोशिश करना है कि कोई कॉन्सेप्ट को अप्लाई कैसे करना है गेटिंग माई पॉइंट ओके चलो लेट्स टॉक अबाउट फर्दर so what is going to be the displacement so we know the displacement is the shortest distance between initial and final position so something has moved 3 meter east and then 2 meter west so what is the shortest distance between initial and final so initial is a final is C. So initial A and final C. So 3 meter we have moved towards the east, 2 meter we have moved towards the west. So this is going to be 1 meter. So what is going to be the average velocity, beta? So average velocity is going to be the total displacement. No worries, beta. It is my duty only. Okay. So it is going to be 1 meter upon what is the total time? Time is 5. So time is a scalar quantity, right? Okay. So it is going to be 1 by 5 meter per second. Did you get this or not? Please answer me. Bala and you. Please answer me. Yeah. Let's try one more question. See, more question you do, more better you feel. So let's suppose a man goes, see, yeah, very good, Bala. So a man goes from A to B at a speed of at a speed of V1 meter per second, okay, and then returns to B, then returns to B at a speed of V2 meter per second. Okay. Now you need to find the average speed and average velocity. Average speed and average velocity. Okay. Now let's try this one. करिए कोशिश करिए इसको. करिए try to solve it, and also we must try to solve it quickly. We must not take much time in this. Please go for it. Return to A. Sorry, return to A, not B. Return to A. Yeah, please try. I'm very sure we can do it. No worries at all. Bala, wrong answer. Not only wrong answer, it is extremely wrong answer. Please do it again. What is average speed? What is average velocity? See, this is the formula. This is the only formula in the world to find average speed. Bala. After this, we'll starting Newton's law of motion only. Right? One topic is left, that is circular motion. So circular motion will do, and afterwards the next topic is NLM only, Newton's law of motion, right? And also I'll start that question session now. So I was trying to do the questions till the topic I have completed, but this way, uh, so I'll be coming up with questions of the other topics also before I taught them. Okay, that way we'll have some understanding. No, not divided by t. Again, see, Bala, please try to understand this. See, whenever, please listen to me carefully. This every student, whenever you are answering a question, so please do take care that you are answering the question in the form of data that are given in the question. Are you getting my point? See, there is no time given in the question, no distance given in the question. So your final answer must be in terms of V1 and V2 only. There can't be any other thing in the answer other than V1 and V2, right? So see, in the world, see, this is how physics shall be, you know, learned. Okay, I'll tell you one thing. See, we understand that average speed formula is total distance upon total time. We understand that average velocity formula is total distance upon, sorry, total displacement upon total time. Now let's try to think it this way. So someone has moved, a man has moved from A to B. Man has moved from A to B, and then he returned to A at a speed. So he moved from A to B at some speed, at V1 speed, and then he come back to A at V2 speed. So what is happening here? So from A to B when he goes, okay, he followed a Let's suppose the distance he has taken is d, and he moved d with a distance of v1, with a speed of v1. Then he came back to a. So again he has moved the same distance but at other speed, at a different speed, right? But at a different speed. Okay. So returning he has moved with the speed of v2. Okay. So first of all, what is the average velocity? So it is going to be zero right away. How come so? Because average velocity is total displacement upon total time. Now something when has moved from initial position to some position, then return to that initial position. What is the shortest distance between the initial and the final? It is zero only. It is zero only, right? So when the displacement is zero, the velocity is zero right away. Did you get this point? Yes or no? अरे कोई इंसान जहां से चला वहीं वापस आ गया. Someone has moved from some point and returned back to the same point. So what is the shortest this distance? What is the displacement? It is going to be zero. So average velocity is first of all zero. Now let's talk about the average speed. Let's talk about the average speed. So what is going to be the average speed? So total distance. So he moved by d. Firstly, he moved from A to B. So he moved d. Then again he moved d. So this is the total distance, right? From initial position to final d. Then final position to initial back. Okay. Or let's say from A to B. Let's suppose he has moved by a distance of d. Then from B point to A, again he has moved by the same distance d. So the total distance is d plus d. Now what is the total time? What is the total time? So what is going to be the total time? So let's suppose that from A to B, he moved in a time t1, and from B to A, he took t2 time. Because the speed is different, because the speed is different, you are going to take different times, right? Isn't it? You are going to your friend's home, you go by walking, and while returning, the friend of yours has dropped you from his motorcycle. Are both same distance going to take the same time? No, so when speed is different, the time is different, right? Now what is the time? So time is what? Speed is equal to distance upon time, so time is distance upon speed. Now please understand, it's very very simple. What is it? So this is going to be d plus d. So let's call it 2d and t1. So what is the distance? The d distance. What is the speed? v1 plus in t2 time. What is going to be the t2 time? So time is equal to what? Distance upon speed. So this is going to be d upon v2. Please tell me if it is fine or not. Isn't it? Right. Now what is going to happen? So I will write average speed is going to be, so let's call average speed as v. Okay, let's call average speed as v. Yeah, this is now it is right. So this is going to be 2 upon 1 by v1 plus 1 by v2. 1 by v1 plus 1 by v2. Are you getting my point, beta? So it is going to be 2 upon v. Can we write 2 upon v is equal to 1 by v1 plus 1 by v2. 1 by v1 plus 1 by v2. Is it clear, beta? Please answer me. Right? Agreed? Fully. Please answer me. Right? Now from here we can also write so without reading, when you do it, the same thing happen na? V1 V2 is equal to V1 plus V2, and this is going to be 2 by V. So V is going to be 2 times V1 V2 upon V1 plus V2, right? Okay. Now please understand this. You can use this as a generalized expression also. ठीक है? आप इसको एक generalized expression की तरीके से भी use कर सकते हो. How so? See, if someone has moved to the same distances in unequal speeds, you can use this formula. See, let's suppose I'll just try to generalize this. So let's suppose someone has moved a distance d at a speed of v1. Then further he has moved a distance d at a speed of v2. Okay, at a speed of v2. So see, distance doesn't require any direction. Okay, so even though if it is moving in the opposite direction, it says from A to B, then B to A. So the same distance is traveled at two different speeds. right? Now see, let's suppose one more distance. So let's first do like this. So if this is going to happen, so what is going to be the average speed you can take? So for this, remember, equal distances has to be followed. This won't work if the distances traveled is not equal. Are you getting my point? So if two distances are traveled at two different speeds, okay, so this you can use in general. Okay, you can generalize this thing. Let's suppose someone has moved from A to B. Let's suppose he has moved by the distance D, then B to C, then again D, then C to D. He has moved three equal distances at three different speeds, right? In the first case, someone has moved two equal distances at two different speeds, but one can also move three equal distances at three different speeds, right? So in this case, you can use the same formula with a little change. What? 3 by V, you can write 3 by V, 1 upon, so you can have the pattern also now. Please try to realize the pattern. 1 by V1 plus 1 by V2 plus 1 by V3. And V1, V2, V3 is what? Sir, it is the speed to cover these distances. Is it fine, beta? Please answer me. Please tell me yes or no. Do we agree or not? Please give me yes or no. Okay, the new students also please subscribe the channel if you haven't yet. Right? This is clear, right? Sir, we don't trust this. Let's do this. What is the problem? Let's suppose someone has moved a distance D. Someone has moved at a distance for a distance D from point A to B. Then he has moved a distance D at point from B to C, and then he has moved C to D at a distance D. Okay. Now in this case, let's suppose this is V1, this is V2, this is V3. Now you need to get the average velocity. Again, we can use our concept. So what is going to be the average speed? And in this case, average speed and average velocity. Yeah, I'm going to give you another question. Average speed, average velocity are going to be same only because distance, displacement are same in this case. So what is average speed, sir? It is the total distance. What is the total distance? So distance traveled, first case, second case, third case, right? First case, second case, third case, divided by time in the first case, second case, third case. So what is the time in the first case? D upon V1. What is the time in the second case? D upon V2. What is the time in third case? D upon V3. Right? Right? Now they can see in physics. Physics में क्या करता है? इसी को घुमाएगा वो. They will be, playing with this language. They say someone has moved someone has covered a distance in two halves. First half he has covered in V1 speed, second half he has covered in V2 speed. Okay, you have to do the same thing. You have to, yeah, afterwards we are getting the same thing now. This is going to be 3 upon V, then 1 upon V1 plus 1 upon V2 plus 1 upon V3, right beta? Right, the same thing. Understood? Please answer me, all of you. Okay, so see, don't get trapped in the language of the question. And remember, you can do this thing only. You can do this thing only when you are having when the same distance is covered. Okay, no matter what direction. Let's suppose we say that someone has covered a distance. Someone moves from point, or someone has covered our distance, okay, then he returned back by the same distance, so the same thing. So remember, irrespective of direction, if same distance is being covered, you can use this concept. Now let's try this one. Let's try this one. Please do it. Okay, I want answer from you also. Please try to apply the concept बेटा. आप concept use करोगे नहीं तब तक नहीं होगा. करिए कोशिश करिए. Please try to do that. Any answer, my dear? Okay, I'll do. So it says a man covers half distance at v1 speed and other half at v2 speed. So what is going to be the average speed? So again, see, a man covers half distance at v1 speed, other half at v2 speed. Now what is going to be the solution here? So man covers half distance at v1 speed. Okay, so same distance. So basically, two equal distances again are being covered at two different speeds. Okay, half distance with v1 speed, half distance with v2 speed. So two same distances or two equal. So after Bala, we are going to do it in in the. So I was told, see, because you understand that I am working in an academy. So I was told to follow the sequence, right? So I cannot jump to the rotational motion. Okay. After NLM, the next topic is rotational motion that we can do. Okay. But after this, we have to start with NLM. Okay. A man, and what I can do, see, because see, this is Diwali time now. Okay. In Diwali only, I am taking the class. So, like after the Diwali, what I'm going to ask that we can start two topics together. One I can take from 12th physics, or I can take the part two, thermodynamics, fluid mechanics, or the properties of solids. Okay, I may start that also, so I can take up two topics together. Okay, so that we can complete the syllabus in less time, right? So it says a man covers half distance at v1 speed, and also see, you must understand is that since I am working for some organization, so I have to follow, right, what they are asking me. This is how things work, right? See, I'm that kind of a person. I'm very truthful to the students, right? So everything is not in my hand. Please try to understand this. See, if I want to teach, like I want to teach you 12 hours a day and want to complete this to December, January, I can do that. But see, I am working in an organization, so they tell me what to do, right? This is the fact. Okay, okay. So I'm trying my part, whatever in my hand, Bala, right? So see, a man covers half distance at v1 speed and another half at v2 speed. एक ही आपको ये क्वेश्चन समझ में नहीं आया बेटा? ये बताइए, ये बताइए दोस्त कि हाफ डिस्टेंस, तो एक इंसान हाफ डिस्टेंस चला फिर अगला हाफ चला, मतलब आपको सिर्फ ये देखना है दोस्त कि कोई चीज अगर सेम डिस्टेंस चल रही है, भाई हाफ चला मतलब डी चला, फिर हाफ मतलब डी बाई टू पकड़ लो, डी बाई टू पकड़ लो. ओके, सो डी बाई टू चला, डी बाई टू चला, तो जब दो सेम डिस्टेंस, दो इक्वल डिस्टेंस चला, अनइक्वल स्पीड से चला, तो क्या फॉर्मूला लग गया बेटा? टू बाई वी इज इक्वल टू वन बाई वी वन प्लस वन बाई वी टू. टू बाई वी इज इक्वल टू वन बाई वी वन प्लस वन बाई वी टू. तो ये कितना हो जाएगा बेटा? ये हो जाएगा टू बाई, तो क्या हो गया? खत्म हो गया क्वेश्चन, वही आ जाएगा, राइट? अमित, हेलो. हेलो अमित कुमार जी, कैसे हैं आप? हाउ यू डूइंग माय डियर? ओके, डन. सो क्या आ जाएगा? यही चीज आ गई, यही आंसर हो गया. v इज इक्वल टू कितना हो गया यहाँ से? टू वी वन वी टू. वी इज इक्वल टू टू वी वन वी टू अपॉन वी वन प्लस वी टू. Amit, what we are doing today here. So we are having a complete revision of motion in a straight line. So on this channel, basically we have completed this topic. Okay, we have completed this topic, but since many of you have recently subscribed to the channel, so I am going you a full revision of this topic. Okay, I hope you guys have subscribed the channel. Now. Okay. Let's try one more question. Just a moment. Yeah. So let's try this question. I'm very sure we can do it. Please try it. So before you are using any concept, any formula, please in physics, please think that whether that thing or that formula can be used in this case or not. Right? Please try to do it. Remember, see, physics is simple only. You have only one formula, right? Average speed, average velocity is equal to average speed is equal to average distance upon average upon total time. Sorry, average speed is total distance upon total time. Average velocity is total displacement and total time. This is the beauty of this subject. You have only one formula and you can use that formula to solve multiple questions. Please try it. Please try it. The live students. Take some time if you require. Yeah, Bala, very good. Amit, Eki, can you guys also try? Now, see, in this case, this funda is not going to work. Why it is not going to work? Because here the same distances are not traveled at unequal speed, right? This is what is important in physics, that when to use what concept, that is the criticality. Okay. So it says a man covers half distance with speed v and remaining half with speeds v1 and v2 for equal time intervals. Find the average speed. So how we are going to do it? So in this you have to apply the concept. So what is the average speed, my dear? So average speed is going to be total distance upon total time. Okay. Total distance upon total time. So what is going to be the total distance? So a man goes half distance. So let's try to draw it. Bala, I understand. Though they are not that difficult topics. I'll try to do something. Okay, I'll try to do something. See, I have no problem in teaching. See, I am teaching something. right? But see, I am told to follow the sequence. Let's see what can happen. I'll just come back to on this. Give me some time. So a man covers half distance with speed v and remaining half with speeds v1 and v2. So half distance, let's suppose this is the distance. So you can take it d by 2, you can take it at t, whatever comes to your mind. Let's take it d by 2 this time. So if if half distance is traveled at what is speed v, now the remaining half is traveled with speed v1 and v2 for equal time intervals. For equal time intervals. So see, now see, don't misinterpret the data first of all. So here's what the students try to think, that they are started thinking that the first half, okay, like between B and C, the first half is traveled with V1, second half is traveled with V2. There is nothing mentioned like this. Okay, we only know that to this distance from B to C, that this distance of D by 2 between B to C is traveled at two different speeds which are taken in two equal time intervals. So now let's see. Let's try to do it. So see, total distance is d by 2 plus d by 2. What is the total time? So see, first half is traveled at a velocity v. So first half is traveled at a velocity v. So what is going to be the time? So it is going to be d by 2 upon v, right? This distance upon speed. So d by 2 upon v plus. Now it says that this distance, the second half is traveled with two speeds v1 and v2 for equal time intervals. Now let's suppose that equal time intervals. So let's suppose equal time intervals means 2t, can I write? Let's suppose it took t speed, t time v1 speed, and the other t2 time, other t time. Okay, it's the same time he has taken v2 speed. Is this fine, beta? So can I write 2 times t? Now, if I am able to find this t in terms of v1 and v2 and d, we'll be able to solve this question, isn't it? Isn't it? Now, please understand this. So, what is the distance? Distance is time into speed. Okay. Now, if I say that between the distance b to c, so what is the total distance between b to c? It is d by 2, right? It is d by 2. Okay. Okay. Now, this distance is going to be equal to t times v1. So, I'll write just like this. Please try to understand the concept. AK and Arvind. So let's talk in this BC section. Let's take it normally. Now in this BC section, this is the BC section of D by 2. Now what is the distance? So firstly, so we know speed is equal to distance upon time. See, this is so simple. We have only one formula. Distance upon time. So distance is going to be speed into time, right? Speed into time. Now someone has moved by the speed of v1. Someone has moved by the speed of v1 for first t time, okay, and then he moved at a speed of v2 with the with t time only, and he reached to c point. This is what it means, na? Please answer me, yes or no. This is what it means, na? Right? So can I write from here that d by 2 is equal to v1t plus v2t? So from here, can we write t is equal to d upon 2 v1 plus v2, d upon 2 v1 plus v2? Is it or isn't it? Right? Now, can we place this t value here? So what is going to be the average speed? So when we put the t value here, what is going to be the average speed, sir? This is going to be d upon d by 2v. Okay, and what is this t? So it is going to be 2, and t is d by 2 v1 plus v2, d by 2 v1 plus v2, right? Is it fine or not? Please answer me. Please tell me yes or no, right? Now from here we can, so d cancel out and we'll get our answer, isn't it? Yes or no? Please answer me. What is so difficult here? Simple, na? Yes or no? Please answer me. Now similarly we can try one more question. Let's do this one. Let's try this one. I'm very, very sure we can do it. Please go for it. Please go for it. Let's try. Let's see if we can do it or not. Please go for it. So again, the similar questions are how can we be doing it? Okay. So now in such question, only concept work. Okay. No formula is going to work for you, but the concept, if you have conceptual clarity in this, then you can work it out. What is going to be the answer? How we can solve this? So very, very simple, sir. See, a bus covers half distance at a speed v and remaining half at v1 for one third of time and uh, v2 for two third of the time. Now let's try to understand the question. So let's suppose there is a bus and it covers half distance. Okay, it covers half the distance. So A, B, or you can take C, D by 2 or D. Okay, whatever comes to your mind first. So let's suppose we have taken the total distance as D. So let's suppose we have taken D by 2. So bus covers half distance at a speed V. So D by 2 distance is covered with a speed V. And the remaining half at V1. So this is D by 2. Okay, so V1, this is covered at V1. Okay, in what time? T by 3 of time. Okay, let's suppose it takes from B to C, it takes T time. Okay, from reaching from B to C, it takes T time. So one third of this time he has traveled with a speed of V1, and the two third of this time he has traveled with a speed of V2. With a speed of V2. So this distance has to be equal to this, right? So what we are going to do? What we are going to do? So what is going to be the average speed, sir? So average speed is the total distance, that is d upon total time. So total time is d by 2 by v plus plus this is the distance. So from here you can relate and get the t. So this is t time. Okay, this is t time, right? Do you agree or not? This is going to be the t time. So what is going to be the t time? So d by 2 is equal to v1 t by 3 plus v2 2 by 3 of 2 by 3 of t. So from here you can get the value of t. So from here you can get the value of t, right? Now you are going to get the value of t in terms of d. So when you place it here, when you place it in this equation, d and d will be cancelled out. These d will be cancelled out, and when the d's will be cancelled out, you will be getting the answer in terms of v1 and v2. Right, guys? Yes or no? Okay, very, very simple, isn't it? Very, very simple. Right, Bida? Okay. So now I guess that you understand the concept of this average speed and average velocity. Very, very simple, right? Now let's move forward with instantaneous speed and instantaneous velocity. Okay, okay. Now, please understand this. So now coming to the concept of instantaneous velocity. Okay, see, see. Now, what I'm going to tell you here. So before you try to learn this concept, I suggest you that if you haven't yet, or if you are good at differentiation, if you are good at differentiation, then it is okay. But if you are having any difficulty in differentiation part, okay, before watching this session, from this point onwards, I suggest you that you go and watch the session on differentiation. So I have given you a complete differentiation with whatever is required for you to learn in differentiation for understanding of physics. Okay, so that much we have done on this channel, some basic formula, basic concept. So before you come to this session, before you watch this video from this point onwards, I suggest you that if you do not have a good understanding of differentiation and integration, so first go and watch the differentiation section, okay, in which I have it would be by the name of class on mathematical tools part 1. Okay, now let's come to this instantaneous velocity. So again, velocity is change in displacement upon change in time. Okay, but here I am going to represent it like this, ds by dt, which is the standard, sign of or standard way of representation of a differentiation quantity or differential quantity, right? So what is instantaneous velocity, sir? It is ds by dt. Now, when we say, see, basically what is the difference? So dt, it is extremely small, okay, very small. So basically when we are seeing the velocity of a body or a particle or anything, when we are reducing the time difference to a very small differential quantity, okay, what we are going to do, so here instantaneous velocity is ds by dt, where dt is extremely small. Dt is what? Dt is very small. So when dt, guys, is very small, that means that when you are seeing it, the time difference you are seeing for calculation of velocity, you have reduce it to a very small time interval. Okay, so basically that is why it is known as instantaneous velocity, because when the time difference is reduced to a very infinitely small, that means you are basically observing the velocity at an instant of time, right? You are, like, in a way, you are freezing the time for a moment, okay, for the moment, and then you are watching the then you are seeing the then you are seeing this thing. Understood, beta? Please answer me. Okay, okay. I hope this is fine to everyone. Now, please understand this. Now, let's understand this. So, this is going to be ds by dt. Instantaneous velocity is given by ds by dt, and dt is very small. Okay. Now, please understand this. So, see, ds by dt is what? So if you have watched that session of differentiation, and if you know the differentiation a little bit, basically ds by dt is the slope of curve under displacement versus time. Okay. So if we can plot the displacement versus time curve, if we can plot the displacement versus time curve, so the slope of that displacement versus time curve is giving you the instantaneous velocity. It's going to give you the instantaneous velocity, right? Okay. So which kind of a question? So see, to understand this, you require a little bit concept of differentiation. You require some formulas of, you know, differentiation to move ahead from here. That is why I suggest you, if you haven't have a bit understanding of differentiation, please watch my session here on this channel by the name of Class on Mathematical Tools 1. So let's suppose we are given with a function of displacement that is s is equal to t square. So we need to find, let's suppose, velocity at t is equal to 1 second, t is equal to 2 seconds, t is equal to 3 seconds, right? We need to find the velocities at these points, and also we need to find, let's suppose, the average velocity, average velocity, average velocity between 1 and 3 seconds, right? Now you might try it, please go for it. I'm very sure we can do. Please go for it, guys. The live student, please answer me. So how we got to do this? So see what we can do. So s is equal to t square, s is equal to t square. So when s is equal to t square, so v is equal to ds by dt. So this v is equal to ds by dt. So when we differentiate it, we'll get 2t. Okay. Because if you see the session of differentiation, I've told you all the basic formulas. Okay. D by dx of x to the power n is nx n minus 1. So it is t square. So when you are differentiating this function with respect to t, what we are getting? We are getting 2 times t. Okay. N t n minus 1. So 2 times t to the power n minus 1, that is 2 minus 1. So that is going to be t. Right. So v is equal to ds by dt, that is 2t. Okay. That is 2t. Now in this case, what is they are asking you? So they are asking the velocity at t is equal to 1 second, t is equal to 2 second, t is equal to 3 second. So what you got to do, sir? So we are going to put this t. So if I say at 1 second, what is going to be the answer? So at 1 second, when we put this 1 here, we are getting v1 as 2. Okay, whatever is the unit. Okay, it can be meter per second, it can be kilometer per hour, whatever. Okay, so I'll just write 2 units. Okay, I'll just write 2 for time being. Okay, now V2 is what? It is going to be 4. V3 is what? It is going to be 6. Right? Understood? So this is going to be the velocity values here. Right? Now what is going to be the average velocity? What is going to be the average velocity? Now please understand this. So what is the average velocity, beta? What is the average velocity? So average velocity is the total displacement upon total time. So here in this case, see, you can consider the motion in one direction, like it is going in one way only, right? From the equation. So see, when s is given as t square, when a function is given, so between 1 to 3 seconds. So let's suppose from 0 to, let's suppose the motion, so displacement shows you the position. Okay, let's suppose the motion is started from this position, and within 1 second this is the distance covered. Okay, so this is the motion between 0 to 1 second, isn't it? Okay, isn't it? Okay, so now if you say that what is the displacement in 2 seconds? So what is going to be the displacement in 2 seconds? It is going to be the displacement of in 2 seconds, right? This much, remember. So whenever you are finding, so it basically shows the position. Displacement basically shows you the position, right? So for position, you always take from the reference, that is the origin you consider. Now they say that the displacement in 3 seconds. So what is going to be the displacement in 3 seconds, sir? We are going to again measure from the origin. Okay, again measure from the origin. So this is going to be S3. Now they are asking you that what is the average velocity between 1 to 3 seconds? Between 1 to 3 seconds. So what is the total displacement between 1 to 3 seconds? This is the displacement till 1 second. This is the displacement till 2 seconds. This is the displacement till 3 seconds. So what is the average? So we are asked about the average velocity between 1 and 3 seconds. Okay. So what is going to be the average velocity between 1 and 3 seconds, sir? So obviously between 1 and 3 seconds, the displacement is going to be like this. This is the displacement between 1 and 3 seconds, right? Do you agree or not? So what is it? So it is basically S3 minus S1. It is basically S3 minus S1. Now when they ask you the average velocity, beta, when they are asking you the average velocity, so how we are going to do it? So if in this cases where you are given with the function of displacement like that, now in this case what we are going to do, so we are going to do like this. Okay, we will be doing like this. Okay, so it is going to be average velocity, it is going to be s3 minus s1 upon total time. So the total time is 2. What is the time between 1 and 3 seconds, sir? It is obviously 2 seconds. Okay, and what is the displacement, sir? It is s3 minus s1. So that is the displacement at the end of the third second minus displacement at the end of the first second upon 2. So this is going to be 3. This is going to be 3. Is that fine? Will you please answer me? Will Is it fine? Do you agree or not? Hmm? I hope yes. Now let's do one more question of it. Then we'll move to the acceleration. Uh, Let's try this one. I'm very sure we can do. Please do it. Very simple question again. Please do it. So how we can do it? So see again, so this is very simple. So now s is equal to t cube minus 6t square. We want to have the velocity at this and this point. So simply what we have to do, so we can differentiate it with respect to time. Okay, so v is equal to ds by dt. V is equal to ds by dt. So if v is equal to ds by dt, it is going to be how much beta? This is going to be 3 times t square minus 12t. 3 times t square minus 12t. Right. Now what is going to be the velocity at 1 second? This is going to be, so let's put the value of t here. So velocity at 1 second, let's call it v1 for time being. So this is 3 minus 12, that is 9. What is going to be the velocity at 3 seconds? Let's call it v3. So it is going to be 3 and so it is going to be 9 into 3. Okay, 9 into 3, right? It is going to be 9 into 3, 9 into 3, that is 27, and minus 12 into 3, that is 36. So again it is going to be minus 9, isn't it? So we have the V1 and V3. Now in this question, this is one thing also written here, that what find the time when the body is at rest. Okay. Now when the body is at rest, what does that mean? So body is at rest, that means velocity is 0. Okay, see, motion and the direction of motion is always given by, the motion and the direction of motion is always given by the velocity. So when it says that when the motion is at rest, when we say that body is at rest, the velocity is going to be 0. Okay, velocity is going to be 0. Okay, so now in this case, what is going to happen? So v is equal to ds by dt. So v, and this is going to be 0. So 3t square minus 12t, it is going to become 0. So it is going to be 3t. T minus 4 is equal to 0. So t is equal to 0 and t is equal to 4. So body will be rest at these point of times, at 0 second and at 4 second. Right? Okay. So find the time when body is at rest. So it is going to be 0 second and 4 second. I hope it is fine to everyone. Isn't it? Okay. Okay. Please answer me. Now, if they are asking you that, like suppose they may ask you this also in this, that what is the displacement when body is at rest? What is the displacement or what is the position when body is at rest? So you put, so if they ask you the position, if they ask you, see, displacement gives you the position, velocity gives you the direction of motion. Okay, okay. Now, so if they ask you the displacement at the time where, the body is at rest, what you can do, you have this time point 0 and 4, you can put it into the function of this displacement and you can get that. Okay, now let's come to the acceleration. So see, what is acceleration? So acceleration is rate of change of velocity, that is change of velocity upon change in time. So basically acceleration is dv by dt. Now remember, when displacement is differentiated with respect to time, we get the velocity. But when velocity is differentiated with respect to time, we get acceleration. Now in this also we know that v is equal to ds by dt. V is equal to ds by dt. So can we write acceleration is equal to, so if I put ds by dt here, we'll be getting d2s by dt square. Do you agree to it or not? Please answer me. Absolutely so. So differentiated, when the displacement is double differentiated, or when the displacement is differentiated two times with respect to time, we are going to get the acceleration. Okay, I hope it is clear to everyone. Now in the same case, if we want to have the acceleration as well, so what is going to be the acceleration? So the velocity is 3t square minus 12t. Velocity is 3t square minus 12t. So what is going to be the acceleration? It is going to be dv by dt. So dv by dt, that is 6t minus 12, isn't it? Okay. dv by dt or d2s by dt square, it is going to be 6t minus 12. I hope it is fine to everyone. So, see, from velocity, you can get the acceleration, and from displacement, you can get the velocity. So, from displacement, obviously, we can get the acceleration as well. Okay. Now, also remember, so since acceleration is dv by dt, can we say that it is basically the slope? What is it? It is basically the slope of v versus t curve, right? So if we plot, so these information are going to help you when you are dealing with the graphs in the kinematics, right? So we are going to talk about the graphs in kinematics also. Okay, so when we talk about the graphs in kinematics, that is also, in that this information, these informations are going to be very, very useful. So acceleration is basically the slope of v versus t curve. That is, if we plot in a motion the velocity with respect to time, the slope of that curve is going to give you the acceleration. Okay, now let's move to the next question. Okay, let's try this one. Let's do it. I'm very sure we can do. Let's apply the concept we have learned. Please do it. So v is equal to 2t square minus 4t. Find acceleration at t is equal to 3 seconds and find average acceleration between 0 to 3 seconds. So how we can do it, beta? Very simple, sir. So when we differentiate the velocity with respect to time, okay, when we differentiate the velocity with respect to time, we are going to get the acceleration. So this is going to be 4t minus 4, 4t minus 4. Now, in this case, what is going to be the acceleration at t is equal to 3 seconds? So it is going to be 8, isn't it? 8 meter per second square. Okay. And what is going to find the average acceleration between 0 to 3? Now, in the same way, what is going to be the average acceleration? Now, in the same way, see, average between 0 to 3 seconds. So what is going to be the acceleration between 0 to 3 seconds? So it is going to be v3 minus v0 and the time, total time. So basically acceleration is total velocity upon total time. So what is going to be the difference of velocity? What is going to be the difference of velocity between 0 to 3? It is v3 minus v0. So we can put it here. So what is this v3? V3 is going to be 9 to 18 minus 12, that is 6. Okay. Minus what is the velocity at t is equal to 0? It is 0 only. And the time is free. So we are going to get 2. Right, beta? Please answer me. Okay. Those who are live can tell me. So see how we can come from the acceleration, how we understood the acceleration, how we can get the displacement, how we can get the time. I hope this is clear. How we can get the acceleration. I hope this is clear to everyone. Right? Okay. Okay. I hope this is clear. Okay. Now, see, please understand this. So see, now we after so see, we have reached till this point. Now please understand this. Now moving ahead from this point, we require some concept of integration, because see what we have done, so we have moved from we have moved in a way that from displacement we got the velocity, from velocity we got the acceleration. Now if we have to move the reverse way, so let's suppose in any case we have the velocity and we want to find the displacement. Let's suppose in any case we may have the acceleration and we may require the velocity. In that case, we have to move in the reverse order. In that cases, we have to move in the reverse order, isn't it? In that case, we have to move in the reverse order. Okay. Now to move in the reverse order, to move in the reverse order, we require to understand the integration. So now from where we can learn this concept of integration, from where we can learn the concept of integration. So see, for moving beyond this point, you require acceleration. So if any of you, or if some of you don't have information, good enough information in integration, what you can do guys, so you can go and watch the session on integration. Okay, so we have done one session on the complete integration, that is required, that much that is required for your understanding, that is required for your understanding of the kinematics. So that much only we have dealt. Okay, so please understand this. So before you move ahead in this session, please watch class on mathematical tools part 2 on this channel. There I have given you the complete information of integration, that how you can use the integration, what is its interpretation, and how you can use this in kinematics, right? Okay, so basically when we are, so I'll just give you one thing. So basically, when we are integrating something, so it is basically reverse of the differentiation process. Like for example, v is equal to ds by dt. Okay, so when you differentiate the displacement with respect to time, you get the velocity. Now, if you follow the reverse process, that is the integration. So if we write it like this, see, ds is equal to v dt. So if we write like this, ds is equal to v dt, and if we integrate this whole thing, then we are going to get the displacement. So if we are having the velocity with us, okay, if we are having the velocity with us, we can integrate, if we have the velocity with us, we can integrate the velocity to get the displacement, right? Okay, please understand this. Okay. Okay, now similarly, if we have what? Similarly, if we have, so acceleration is dv by dt. Acceleration is dv by dt. Uh, नहीं, ऐसा तो नहीं है डिफरेंट बुक में डिफरेंट कहाँ लिखा हुआ है ये? किस चीज का फिजिकल टर्म की डेफिनेशन डिफरेंट लिखी हुई है? लैंग्वेज डिफरेंट हो सकती है, लेकिन मतलब ऐसा तो है ना कि उसका कॉन्सेप्ट डिफरेंट होगा। ठीक है, ऐसा कुछ नहीं है बेटा। आप 10 बुक को नहीं, आप एक बुक को फॉलो करिए, एनसीईआरटी फॉलो करिए बस। नीट के लिए ज्यादा कुछ चक्कर में पढ़ने की जरूरत ही नहीं है ना? चलिए, तो एक्सीलरेशन इज डीवी बाई डी टी, तो एक्सीलरेशन इज डीवी बाई डी टी। तो देखिए, अब इसको अगर आप इंटीग्रेट करें तो फर्स्ट ऑफ ऑल हम इसको ऐसे लिख सकते हैं। देखिए कैसे लिख सकते हैं सर, डीवी इज इक्वल टू ए डी टी। ओके, क्या लिखी है मोशन की डेफिनेशन बताइए? तो ए डी टी, डीवी इज इक्वल टू ए डी टी, दोनों तरफ इंटीग्रेट कर दीजिए तो क्या बन गया, यहाँ बन गया वी इंटीग्रेशन ए डी टी। तो बेसिकली मैं कहना क्या चाहता हूँ, देखिए हमें अगर कभी रिवर्स डायरेक्शन में चलना पड़े तो कौन सी डायरेक्शन में चलना पड़े, कौन सी डायरेक्शन में चलना पड़े, बताइए क्या क्या है डेफिनेशन मोशन की, बताइए कौन सी बुक में क्या पढ़ा बेटा आपने? तो बेसिकली कभी भी अगर आपको रिवर्स डायरेक्शन में चलना पड़े, मतलब जैसे अभी हम क्या कर रहे थे सर, अभी हम डिस्प्लेसमेंट से वेलोसिटी निकाल रहे थे। अगर वेलोसिटी से बेटा डिस्प्लेसमेंट निकालना हो तो क्या करना पड़ेगा बेटा, इंटीग्रेशन करना पड़ेगा। सिमिलरली अभी हम एक्सीलरेशन, वेलोसिटी से एक्सीलरेशन निकाल रहे थे, अभी हम वेलोसिटी से एक्सीलरेशन निकाल लेते हैं। अब मान लो कभी हमें एक्सीलरेशन से वेलोसिटी निकालना पड़ा, कभी हमें एक्सीलरेशन से वेलोसिटी निकालना पड़ा, तो जब हमें एक्सीलरेशन से वेलोसिटी निकालना पड़ेगा तो हम क्या करेंगे बेटा, हम उल्टा चल पड़ेंगे। हम क्या करेंगे बेटा, हम उल्टा चल पड़ेंगे, हम इंटीग्रेशन करने चल पड़ेंगे। तो बेसिकली ये सब करने के लिए आपको थोड़े से फॉर्मूलाज की रिक्वायरमेंट है, सो प्लीज आप उसको जा करके देख लीजिएगा सेशन, अगर आपको आइडिया नहीं है ऑफ द इंटीग्रेशन। अच्छा, एक चीज और याद रखिएगा, इंटीग्रेशन हमेशा एरिया देता है। इंटीग्रेशन हमेशा, इंटीग्रेशन जब आप किसी चीज का करते हैं तो बेसिकली ये आपको एरिया अंडर द कर्व देता है। ठीक है, ठीक है। देखिए, डिफरेंशिएशन किसी कर्व का स्लोप देता है, तो इंटीग्रेशन किसी कर्व के अंदर का एरिया देता है। इस चीज का ख्याल रखेंगे। चलिए एक क्वेश्चन बनाते हैं। तो मान लीजिए कोई फंक्शन ले लेते हैं, मान लीजिए हमारे पास दिया है v इज इक्वल टू टी प्लस वन, v इज इक्वल टू टी प्लस वन दिया हुआ है, तो आप डिस्प्लेसमेंट निकालिए। चलिए, नमस्ते प्रमोद, कैसे हो, क्या कर रहे हैं हम यहाँ पे बता देते हैं। तो मेरा नाम है डॉक्टर उमा शंकर त्रिपाठी, और हम क्या कर रहे हैं बेटा, यहाँ पे पढ़ने की कोशिश कर रहे हैं मोशन इन अ स्ट्रेट लाइन। सो इस चैप्टर पे बेटा ऑलरेडी हमने ये चैप्टर खत्म कर दिया था, लेकिन एक वन शॉट रिवीजन कर रहे हैं, जिसमें हम इसके टोटल जो भी कॉन्सेप्ट हमने पढ़े हैं उसको क्विकली रिवाइज कर लें और एक सेशन के अंदर इसको डील कर लें। ठीक है, उसी में आगे बढ़ रहे हैं। चलिए डिस्प्लेसमेंट पे बात करते हैं। लेट्स लेट्स ट्राई टू, एंड दिस इज एन इंग्लिश चैनल। ठीक है, सो लेट्स ट्राई टू फिगर आउट व्हाट इज द डिस्प्लेसमेंट। करिए बेटा, डिस्प्लेसमेंट फाइंड आउट करिए, इंटीग्रेट कर लेंगे इसको। लेट्स ट्राई टू इंटीग्रेट इट। फिर निकालिए डिस्प्लेसमेंट, निकालिए बेटा। लेट्स ट्राई टू फाइंड आउट द डिस्प्लेसमेंट। लेट्स ट्राई टू फाइंड आउट द डिस्प्लेसमेंट। प्रमोद, आंसर तो बेटा आपका सही है, लेकिन कुछ एक चीज मिसिंग है जो बहुत इंपॉर्टेंट है। So see, very simply, just I want to convey one thing, that so when we have velocity, we can have it integrated to get the displacement. So now if I integrate this velocity with respect to time, I'll be getting, see, integration of t, it is going to be t square by 2. Integration of 1, it is going to be t. So displacement is t square by 2 plus t. This is not correct because we have to add one constant of integration as well. Please understand this. Whenever integration happens to be without any limits, okay, without the limiting values, okay, then there will always be a constant of integration, right? Now, this constant of integration value can be found using the boundary condition. That is the information which is given in the question. We'll see to it. Now, in this question, if I add on, if I write like v is equal to t plus 1, so find displacement. If I write find displacement uh, from 0 to 2 second, 0 to 2 second. Now, in this case, how you are going to do it? So see, in this what happens, so we are given with 0 to 2 seconds. So what we can do, so we can, in this case, we can integrate it between the limits, okay, t plus 1 dt. Now, when you are putting the limits to some integral, this is what we call as the definite integral. This one is indefinite integral. So, whenever indefinite integral is there, we have to have a constant of integration as well. Okay, and that constant of integration value we have to find in many cases. Now, in this case, what is going to happen? So s is equal to 0 to 2 t plus 1 dt. T plus 1 dt. Okay. So what we can do, we can integrate it. So it is going to become t square by 2 plus t. Now we are going to put limit over it like this, 0 and 2. See how we are going to do. So this is the upper limit, this is the lower limit. So we are going to put these limits into it. So this is going to be 2 square by 2 plus 2, okay, minus, so t 0 0, so it will become 0, so this is going to become 4, okay. No need of constant of integration. So see where to get the constant of integration, where not to use the constant of integration. Is it fine? Please answer me. Right. Now in the same way, if it is asked, like suppose again taking the same thing, like the language is given like this, v is equal to t plus 1. Now find displacement at end of 4 second, at the end of 4 second, if the body if the body if the body is at origin initially. Now can we please try this question? Let's try this one. Can you please try it? Please do it. The live student, you may try to answer this one. Please go for it. So see how we can do it. So v is equal to t plus 1, v is equal to t plus 1. So when v is equal to t plus 1, as at the end of 4 second we want to have if the body is at origin initially. Okay. So to find the displacement, so we need to integrate this. So when we will be integrating, it will be t plus 1 dt. It will be t plus 1 dt. So displacement is going to become t square by 2 plus t square by 2 plus t, and since we do not have used the limit, so we can have the constant of integration, that is c. So it will become t square by 2 plus t plus c. Now as at the end of 4 seconds, if the body is originally, if body is at origin initially, okay, so body being at origin initially, so what does that mean? So see, this is the information given in the question to help you to find the constant of integration. See, to find the value of the constant of integration, you are requiring to use the information given in the question. Like for example, in this question, it is given that the displacement at the end of the 4th second, if the body is at origin initially. So what is the displacement at the end of 4th second if the body is at origin initially? So see, what is the information? The information here we have is that when t is equal to 0, when t is equal to 0, because initially this was mentioned na? So when t is equal to 0, the displacement, okay, is 0. So when t is 0, displacement is 0, so c is going to be 0. C is going to be 0. So c is going to be 0. Let's put it in this equation. So when this is going to be 0, so this is going to be the function of the displacement. Okay, right? T square by 2 plus t. Right. Now, what is going to be the displacement at the end of the 4th second? So the displacement that going to be at the end of the 4th second. So we can put the value of t here. So this is going to be 4 square by 2 plus 4. So it is going to be 12 meters. So what is the displacement at the end of the 4th second? It is going to be how much? It is going to be 12 meter. Understood, beta? It is going to be 12 meter. Understood? I hope it is fine to everyone. Right. Now moving ahead, let's do one more question. Now let's suppose we have v is equal to 2 times t. V is equal to 2 times t. Find displacement at 3 seconds. Find displacement at 3 seconds. If at t is equal to 0, if at t is equal to 0, body is 2 meter. If at t is equal to 0, body is 2 meter behind origin. Okay, please do that. Please do it. I'm very sure we can do. Please do it, beta. See, this is a very simple concept again. Okay. So see, we are going to solve it in the same way. So when we have velocity is equal to 2 times t, velocity is equal to 2t, find displacement at 3 seconds if at t is equal to 0, body is 2 meter behind origin. Body is what? Body is 2 meter behind origin. So what we are going to do? So v is equal to 2t. V is equal to 2t. So when v is equal to 2t, what is going to happen? So v is equal to 2t. That means we are going to have to find the displacement at 3 seconds if at t is equal to 0, body is 2 meter behind origin. So v is equal to 2t. Okay, v is equal to 2t. So what we are going to do? So we are going to find the displacement. So to find the displacement, we are going to integrate it. So it is going to be integrated like this. So what is going to be the displacement? It is going to become 2t square by 2, that is t square plus c. T square plus c. Okay. Now you want to find the displacement at 3 seconds. So for displacement at 3 seconds, first of all, you need to find the value of C. So how we can find the value of C? So again by using the information given in the question. So what is the information we have in the question? So if at t is equal to 0, body is 2 meter behind origin. That is initially when the motion is started, the t is equal to 0. So body is 2 meter behind origin. That means the displacement is minus 2 meter. The displacement is minus 2 meters. So let's use this information here. So s is equal to minus 2. So c is equal to minus 2. C will become how much? C will become equal to minus 2. So if we put it here, so this is going to become t square minus 2. So what is displacement at t is equal to 3 seconds? So this is 9 minus 2. This is 9 minus 2. So the displacement is going to become 7 meter. And displacement is going to become 7 meters. So this is how you can deal. This is how you can deal with such problems in which velocity is given. Oh my god. So this way you can deal with such problems in which velocity is given and you need to find the displacement, right? Now in the same way, if we have the acceleration, if we have the acceleration and we want to find the velocity, so again we can do this integration thing, right? Like for example, if it is given in a question, if it is given in a question, let's suppose uh, Popat Shindeji. Very good morning. Very good afternoon. Hello. Okay. Shri, what we are doing here, so we are having a complete revision of the motion in a straight line. So on this channel, we have already completed this topic before, but since many new students have joined the channel, so basically we are having a one short quick revision of this particular chapter. Okay, so that in one session we can have all the important concepts of motion in a straight line. Okay, my name is Dr. Shankar Sir. Okay, now let me continue with the session. So, if acceleration is equal to 3t square, a is equal to 3t square, find the velocity, find v at, we have to find velocity at t is equal to 3 seconds. We need to find the velocity at t is equal to 3 seconds. If initially the body, if initially the body is at rest. Okay, let's try this question. I'm very sure we can do it. Okay, let's try this one. I'm very sure we can do. Let's try it. Please try it. So see, very simply we can do. How we can do so? So it says A is equal to 3t square. Find velocity at t is equal to 3 seconds if initially the body is at rest. Okay. Now what is said here? So the velocity, find velocity at t is equal to 3 seconds if initially the body is at rest. So see how we got to do this. So see, it is very simple. Okay, so acceleration we want to find the velocity. Now from acceleration, if we want to move towards the velocity, we can write velocity as integration of a dt. Okay, so this is going to be 6t, 3t square, that is 6t. So velocity is going to be how much? So it is going to be 6 times t plus c. Again, since we are integrating using indefinite integral, so basically what we are going to have a constant of integration too. Now in this case, what is going to happen? Okay, so if initially the body is at rest, so what is the information given? So the information we have is that initially the body is at rest. So initially body is at rest, that is t is equal to 0, and body at rest means the velocity is 0. So t is 0, velocity is 0. So when t is 0, velocity is 0, c is also 0. C is also 0, right, beta? C is also 0. Okay. Now, c being 0, so we can say the velocity is what? So c is equal to 0, that means the velocity is given by t cube. Okay. Oh, sorry, I have just one mistake. I have differentiated instead of integration. Just give me a moment. Yeah, so velocity we need to integrate it. So it will become 3t cube by 3 plus c. Sorry, my mistake. Okay, so rather than integrating, I have differentiated. So velocity acceleration is 3t square. So it is going to be 3t cube by 3 plus c. So basically it is going to become t cube plus c. So velocity is going to be t cube plus c. Now when we are putting this information, which is it said that if initially the body is at rest, so initially body is at rest, that is t is equal to 0. At t is equal to 0, v is also 0. So if we put this information here, so t is equal to 0, v is equal to 0, so that means c is also equal to 0. Now in this case, what is going to happen? So we can write v is equal to t cube because c is equal to 0. So now it is asked that what is the velocity at 3 seconds. So we can put 3 here. So this is going to be 3 cube. 3 cube, that is going to be how much? This is going to be 27. Okay, 27 unit. I hope it is fine to everyone. Okay, so 27 meter per second. Right, beta? 27 meter per second. Okay, okay, wonderful, wonderful. Now, so let's see one more thing. Okay, so let's see one more question. So a is equal to x square. A is equal to x square. Now we need to find v. Okay, when x is 2 meter, right? X is 2 meter. Okay. So one more information is also given in this question. So given that at x is equal to 0 meter, at x is equal to 0 meter, body is at rest. Body is at rest. Okay. Now let's try this question. Let's see if we can do it or not. Please go for it. Please try it, guys. Let's try to do it. I'm very, very sure we can do. You are supposed to use some concept here. Please try to do that. So see how we can do it. So see, very, very simple. Very, very simple. So what happens here is student makes a mistake. They say so here acceleration is given as a function of x, not as a function of time. In previous questions, basically acceleration and all these things were given as a function of time. Here, in this case, it is not given as a function of time. Now, in this case, what is we supposed to do? So, see, acceleration is what? So, it is dv by dt. Okay, it is dv by dt. Now, can I write it like this also? Can I write it like this also? So, how we are going to write it? So it is dv by dt. It is dv by dt. So can I write it like this? dv and dx by dx. Can I multiply dx and dx to this? Yes or no, Buddha? Please answer me. What do you say? Yeah, absolutely, sir. We can do like this. So now please understand this. This dx by dt is what? So this dx by dt is velocity only. This dx by dt is velocity only if we see this dx by dt together. So this is basically x is what? It is x is some sort of a displacement and t is time. So dx by dt is v only. So it will become v dv by dx. It will become v dv by dx. I hope it is fine to everyone. So acceleration is v dv by dx. Okay. 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 Now so acceleration is v dv by dx. Now, from here, what we can do, so we can write acceleration is, so we can put x square here, okay, and this is the, so we'll take dx there, so x square dx plus v dv. Can we write this expression like this? Yes, sir, absolutely, no problem at all. Now, if we write like this, x square dx is equal to v dv, x square dx is equal to v dv. So this is going to be x cube by 3. So if I integrate both the sides, so it will become x cube by 3 is equal to v square by 2, v square by 2 plus c, v square by 2 plus c. I hope it is fine to everyone. Okay. Okay, so x cube by 3 is equal to v square by 2 plus c. Okay, so remember that we need to use only one constant of integration. It is not like that you use two constant of integration. Understood, beta? Okay, you need not to use two constant of integration. Like some people, some students, what they think that, sir, we are integrating on the left side, we are integrating on the right side, so we need to use the constant of integration on both the sides. It is not like that. Okay, so this is the expression we have found of between velocity and x. Now let's use the information given in the question. Okay, let us use the information given in the question. So what is the information given in the question, sir? So information is given that at x is equal to 0, body is at rest. So when x is equal to 0, body is at rest. So if I put this information, body is at rest, that means velocity is 0. So if I put x is equal to 0 here, velocity is equal to 0 here, so we'll get c is equal to 0. We will get c is equal to 0. Okay. Hello Ganesh. Okay, now if we, so I'll just talk to you. So if we c is equal to 0, we put here. So we need to find the velocity when x is equal to 2 meters. So 2 meter, that means 2 cube, that is 8 by 3. This is v square by 2. So this is going to be 16 by 3 v square. So v will become 4 by root 3. So this is the velocity at this. Okay, this is the velocity at this point. Yeah, Ganesh, welcome to the session, my dear. So my name is Dr. Shankar Sir, and in this session we are having a revision of the motion in a straight line. Okay, so basically, motion in a straight line we already have completed previously, but in this session we are trying to have a complete revision of the same because see, some of the students have joined the channel very recently and they wanted to have a quick revision session of all what we have dealt till now. Okay, okay, so this is what is happening here. Okay, so we just have solved this question. Ganesh, do you have any query or anything that you want to ask me regarding the channel or regarding me or regarding anything? Yeah. Okay. Now, in this session till now, what we have done, so we have understood the concept of now, firstly, distance displacement, then we have understood average speed, average velocity, then we have understood instantaneous speed, instantaneous velocity, then we have understood how to calculate the displacement from the velocity if given, and how to find the velocity if acceleration is given, right? And also we have found that if displacement is there, how to get the velocity, if velocity is there, how to get the acceleration, right? Okay, okay, so this much we have done till now. In this session there is in this motion in a straight line, there is one very important concept, that is equation of motion. Okay, equations of motion. Okay, equations of motions. So what are the equations of motion? Okay, so what are the equation of motion and how they derive? So they are derived using all these concepts only of differentiation and integration. So there are three. V is equal to u plus at. Okay, s is equal to ut. S is equal to ut plus half at square. Okay, and third is v square is equal to u square plus 2as, u square plus 2as. So basically these are the equation of motion. Okay, very very important, very very useful. So not only you use these equations in motion in a straight line, but to some extent we use these equation in motion in a plane also. Like lastly, in the last session I have done the projectile motion. So projectile motion, if you remember, we have used these equations only, right, isn't it? In relative velocity, in 1D, relative velocity 2D, in all those topics we have used these equation only, right? Okay, now to use this equation there are few things that you need to be taken care for. First of all, these equation can only be used when the motion is under constant acceleration. Okay, acceleration must not change. Okay, acceleration must not change during the motion. So if acceleration remains constant, then only we can apply this equation, these equation. Okay, and basically one very beautiful application to this is motion under constant gravity. Motion under constant gravity. Okay, see what is motion in the constant gravity. So see, basically when something is like let's suppose that you have thrown something. We must have seen this kind of a question, right? Like, so we have thrown something from a tower or from the ground. What is the maximum height it reaches? What is the time it requires to fall down? Okay. So in these, we have to use these very equations only. There is nothing, different in this rather than using this equation. Okay. Okay. So see how we can do. So we'll do some 2 3 questions so that we revive our concept of it. So when we talk about the motion and the constant gravity, we are going to use these equations. Now, there is a sign convention that we may choose to follow. Okay, just for the ease of use of these equations. So what are the sign convention? See, sign convention. So first of all, whenever you are seeing the motion, you can see with some reference. Okay, when you are seeing the motion, you are seeing with some reference. Okay, so what reference we can take? Let's suppose we have taken a reference like this. Okay, now please understand this. Whatever, see, sign we require. Why we require sign? So we require the sign for what? So we require the sign for the vectors. Are you getting my point? We require the sign for the vectors. Okay. So see, this sign convention you can follow for each of the vector in this equation. So what are the vectors here? So sir, we obviously know, I guess, that v is equal to v is the final velocity. These are very famous equation, right? V is the final velocity, u is the initial velocity, a is the acceleration, t is the time. Now, what are the vectors? So this sign convention is for vectors, that is u, v, initial velocity, final velocity, displacement, acceleration. Okay. So what is the sign convention that we are going to follow here? So see, whatever vector is in upward direction from some reference, we are going to take it positive. Let it be anything, displacement, velocity, acceleration, right? This is going to be positive. And when something is down in the downward direction from this reference, we are going to take it as negative. This is what we are going to do. Now, when we are talking about motion under constant gravity, see, acceleration due to gravity always acts in the downward direction. So acceleration due to gravity always acts in the downward direction. So in this particular topic, we need to take g always as negative. Okay, we always have to take minus of g, right? We always have to take minus of g. That is the only thing in this particular equation. So let's try to do it with the help of some questions. Okay, okay. Let's try to solve 1 or 2 questions. You will be able to understand it very, very easily. Okay, let's try this question. Let us try this one. I'm very, very sure we can do it. Please go for it. Let us see if we can do it. Let's do it, beta. Very simple question. So see, these questions we only have to apply the equation of motion. Please do it. So how can we be dealing to it? So see, a stone is dropped from a tower of 20 meter. Find the time taken to reach the ground, is speed just before hitting the ground. So see, first of all, please draw the figure. So we have a tower, and what is the height of this tower? Height of this tower is 20 meter. Okay, height of this tower is 20 meters. So see, using this equation is very important. Let's try to understand the use of it, because using this only you can understand the projectile motion, relative velocity, Newton's law also, you'll find some use to it. Okay, so now this is 20 meters. So it is dropped from this tower. So basically when it is dropped, so it is dropped like this. That means it has initially zero velocity. So now when it is dropped, let's suppose this is A point and it is dropped. So obviously and eventually it is going to, hit the ground. Okay. So let's suppose it hit the ground like this. Okay. So it falls and hits the ground. So see, whenever you are using these equations, guys, whenever we are using this equation, we have to be very clear about one thing, that from which point to which point we are going to apply the equation. Okay. Now let us apply from A to B. Okay, let us apply from A to B. So what is we need to find? So we need to firstly find the time taken. Now let's see what is the information we have. So initial velocity is 0. Okay. Displacement is what? Sir, it is minus 20 meters. Sir, how come minus 20? We have taken the reference as A. We have taken the reference as A. Okay. Now, when we take the reference from A, the point B is in the downward direction. So that means displacement is minus 20. What is the other information we are having, sir? Acceleration. It is always in the negative direction, because acceleration due to gravity always acts downward. So when it always acts downward, this is minus 10 meter per second square. So what is required? So we require to have the time. So first of all, at what time it hits the ground, at what time it hits the ground. So what we can do, we can apply the equation. So we understand S is equal to ut plus half at square. This is going to be the first part. Ut plus half at square. So what is S? So this is minus 20. U is 0 plus half, this is minus 10, and this is t square. So t is going to be 2 seconds. T is going to be 2 seconds, isn't it? How come, sir? So see, 0 will be cancelled out, minus minus will be cancelled out. This is going to become 4. So this is going to become 4. That means t is going to become 2 seconds. Now, time taken to reach the ground, this is 2 seconds. Right? Now, what is going to be the speed just before hitting the ground? So how we can calculate it? So, sir, for that we want final speed, no? So, what is the final speed? So, we can use this one. V is equal to U plus AT. Now, see, don't get confused in this. Many students think, sir, oh, sir, when it is going to hit the ground, the velocity at that point must be 0. When it hits the ground, the velocity must be 0. So, it is not like that, Veda. It is absolutely not like that. We always take, so whenever something is hitting something, we basically consider the velocity. We basically consider the velocity just before it hitting the ground, just before it hitting the ground. I hope it is fine to everyone. Okay, so see, final velocity is not zero. Don't consider it to be zero. So v is equal to u plus at. So what is the initial velocity, sir? This is zero. What is the acceleration, sir? This is minus of 10. And what is this t? It is going to be 2. So v is coming out to be minus 20 meter per second. Okay, so minus, what does that mean? So we are asking about the speed. So basically, what is the velocity? Velocity is minus 20 of j cap, right? 20 of j cap. J cap is what? J cap is the unit vector in the y direction. Okay. Okay, so what is the speed? So speed is obviously the magnitude of velocity. We understand. So speed is the magnitude of velocity. That means what we are going to get. So it is 20 meter per second. So at what speed it is going to hit the ground? It is going to hit the ground at a speed of 20 meter per second. Okay. Now let's try one more question so that this concept is completely clear and we use everything into this. Let's try this one. I'm very sure we can do. Please try it. Let's try it. I'm very sure we can do it. No problem at all. Please go for it. See, we need to use the same concept, same equation of motion using the sign convention that I have told you. You will be able to very easily do this question. Okay. Great. Please do it. See, we need to apply the same concept. Please go for it. So how we can do it? So it says a ball is projected vertically upwards from a tower of height 20 meter at a speed of 5 meter per second. Find the maximum height. Find the maximum height reached by ball from ground. Okay. So what is asked here? So first of all, in this the ball is projected vertically. The ball is basically projected vertically upwards from a tower of height 20 meter at a speed of 5 meter per second. So now in this case, what is going to happen? Let's try to do that. So it says the ball is projected vertically upwards from a tower of height 20 meter at a speed of 5 meter per second. Okay. Now please understand this. So let's suppose we are having a tower of height 20 meter. See, in this question, you will be able to understand mostly everything. Okay. And now the ball is projected vertically upwards from the tower of height 20 meter at a speed of 5 meter per second. So it is projected vertically upwards. Let's suppose this is point A and it goes to upward direction. Okay. No worries. The maximum height reached by the ball. So let's suppose the maximum height reached by it is B. Okay. From the ground we have to find. So let's suppose this is H. Okay. This is H. So now if I consider, now please understand this. So when you are now you have to think a little bit here. So whenever you are projecting something from the height or from any way, so vertically when you are throwing something or you are projecting something vertically, basically it is going to reach a height. Okay. Because see, acceleration. So think practically. So when we are throwing something upwards, so basically it is having the motion against the acceleration due to gravity. So its velocity is going to decrease with time, and there will be a moment at which its velocity in the vertical direction is going to be zero. Now, at that moment, what is going to happen? So, at that moment, it is going to start its descent, that is the downward motion. So, at that point, when the maximum height is reached, basically the velocity becomes zero. So, now if I consider the motion between A to B, if I consider the motion between A to B, what is the initial velocity, sir? So it is said that it is thrown at a velocity of 5 meter per second. Now, what is the final velocity? So when it reaches the maximum height, the final velocity is going to be zero. Okay. Now, what we can do? So, what is the height? So, v square is equal to u square plus 2a as we know. So this is going to be 0. U is 5 square. This is minus 2 into 10. So why you are using minus? Because the acceleration due to gravity is always in the downward direction, and the sign that we have seen in that, what is happening? So acceleration in downward direction. So G is in the downward direction. So it is minus. So what it is going to become, beta? So it is going to become 25 by 20. That is how much? 25 by 20. Right? It is going to become 25 by 20. So 25 by 20, that is 1.25 meter. 1.25 meter, isn't it? Yes, sir, absolutely, sir. So now in the first case, what is asked, beta? So in the first case, in the first part, it is asked, what is the maximum height reached by the ball from the ground? So 20 is the height of the tower, and this is 1.25. So it is going to be how much? It is going to be 21.25 meter, right? I hope this is fine to everyone. Right, 21.25. Now we are moving ahead. So now in the second part of this question, let's see what they are asking for. So live students, if you want to, try it, always try it. And those who are, watching in the recorded session, please pause this video, try the question yourself, and then see the solution to it. That will be helpful to you. Now it says time when it passes from its mean position. Now what is going to be the time when it passes from the mean position? Now first of all, what is the meaning of it? So see, when it reaches the maximum height, it is going to have a downward motion afterwards. So it is going to come downwards like this. Okay. Now what is the mean position? So mean position is this only. Okay, so mean position is what? Mean position refers to the position from where it has been thrown. It is basically the position from where this has been thrown. Okay, okay, so basically this is going to be the C point, right? Now, if I consider the motion between A to C right away, what is going to be the displacement, sir? So it is zero only. See, this is the beauty. So here the displacement is going to be zero. Why, sir? Because see, there is no distance, there's no vertical distance, or there's no vertical difference between A and C. Okay, so what is the displacement between A to C? It is going to be zero. Now, if I apply the motion equation between A to C, so we have what is U? U is how much? Plus 5 meter per second. It is plus 5. Acceleration, it is always, when it is due to gravity, it is always in the downward direction, so that is going to be minus 10. Okay, and time is ours. Okay, time is ours. So we have S, we have U, we have A. Now we understand S is equal to ut plus half at square. Ut plus half a t square. So this is going to become, S is going to become 0. Okay, so u is going to become 5 of t plus half. Acceleration is going to be minus 10, and this is going to be t square. This is going to be t square. So from here it will become t, okay, and this is going to be 5t minus 5t square is equal to 0. So 5 will be cancelled out. It will become how much? So it is going to become t 5. So 5 is cancelled out. So it is going to be 1 minus t. It is going to be 1 minus t is equal to 0. So time t will become 0 and t is going to become 1. Right? T is going to become 0. T is going to become 1 second. I hope it is clear to everyone. Right? So see, sir, we are getting 0 and 1 second. So what does that mean? So see, basically in this equation, when you are applying, so you are taking S as the displacement. So basically this times are telling you, this is trying to tell you that at what timings or at what point of time this particle or this body will have this position. So it will be in this position at 0 second and at 1 second. Okay. Now let's come to the third part. Let's come to the third part. So 0 second is what? What shall be your answer? So answer shall be 1 second. 0 second is the time it shows when the motion is just started. Okay. The position when motion is started, that is t is equal to 0. Right. Now let's move to the third part. Find the speed of the ball just before hitting the ground. So just before hitting the ground, so again, so afterwards, what is going to happen? So it is going to reach to this D point. Ultimately, it is going to strike the ground. Okay. So now it is asked that at what velocity or what speed it is ball is going to hit the ground. So at what speed it is going to hit the ground? So we have initial velocity, that is plus 5. Acceleration, this is minus 10. Okay. Acceleration, this is minus 10, and uh, okay, so we have to find the speed. Okay, So we have A, we have U. Do we have the displacement? Yes, sir, we do have the displacement also. So I am now considering the motion between A to D. So what is going to the displacement? It is going to be minus 20. It is going to be minus 20. Is that clear? But please answer me. Hmm? It is going to be minus 20, right? So what we can do, sir, now we can apply the equation. So see, we have initial velocity, acceleration, and the displacement. We have initial velocity, acceleration, and the displacement. So what we are going to use? So we are going to use this formula, S is equal to ut plus half a t square. So this is going to be minus of 20. This is going to be minus of 20. This is u, that is 5. And we have t plus half. This is of minus 10. And this is t square. So what it is going to become? So this is going to become how much? So it will be becoming from here. So see, from here we'll get a quadratic equation, isn't it? Okay. Okay. So all see, we can do like this. So basically, we have to find the final velocity. Na? So why unnecessary we are, because for this we have to find first of all the time also. So we can use this equation easily. Na? V square is equal to u square plus 2as. So final velocity square is equal to initial velocity square plus 2 into minus 10 into minus 20. Okay, so how much it is going to become, sir? It is going to be 425. Right, so v square is equal to 425. So v is plus minus root 425. So what is going to be the velocity? It is, what is going to be the speed? It is obviously root over 425 meter per second. Root over 425 meter per second. I hope it is fine to everyone. Okay. Now let's take care of this last part of this question. So find time taken to reach the ground. So find time taken to reach the ground. So again we can consider the motion from A to D only. We can consider the motion from A to D only. And we have this information. Now we have the velocity. So we can use V is equal to U plus AT. V is equal to U plus AT. Right? Or we can use the previous equation that I was using, as is equal to ut plus half a t square, isn't it? So as we have, that is minus 20. So let's suppose this question is not asked that what is the final velocity. We must have chosen this equation. So u is equal to 5 and this is t plus half, this is minus 10 and t square, right? So from here we can find the value of t. Okay, from here we can have a quadratic equation, and this is going to be t square minus t minus 4. This is going to be equal to 0. So from here, when we sort this out, we'll get two values of t. So out of the two value, whatever is the positive value you see, that is what you are going to use for your uh, answer, right? Okay. So guys, this was the concept of the motion and the gravity and the use of equations of motion. Okay. Now in motion in a straight line, we have graphs in kinematics and relative velocity in 1D. So that topics I have recently covered. So a graph in kinematics, basically it cannot be, a short-term discussion. Otherwise you get confused. So I'll not be covering the graphs in kinematics here. And relative velocity in 1D, I just have covered 2-3 days before. So I don't think there is a need of revision of that for this time being. Okay. So in this session, except these two topics, I have completed the motion in a straight line. I have dealt with all the concepts of it. So I hope you guys have enjoyed this session. So if you are haven't watched the sessions of the motion in a straight line, you have this session as a one-shot complete revision session. So guys, I'll be keeping to this point in this session, and I'll be coming up with more such concept, more such sessions, and we'll be doing the physics this way. So I hope you have enjoyed the session. So thank you very much. Wish you all the best, and please do subscribe the channel.